Okay, so hi and welcome to the Keshe Plasma Reactor Group once again. It's Tuesday night, September 13th, 2016. We all made it through 9/11 of 2016, and I don't even think there was any incidents that I know other than a peace in Syria. Who would have guessed? But yeah, so anyways, here we are, and we will begin tonight's festivities, I believe, with a presentation by Lee Coates on his latest developments, and we'll just take it from there. All right, let me patch through here.
Hello, everybody.
Just a second, Lee, I got to... it's a double procedure to pin you on my second screen. There we go. Now we're ready.
Ouch, I just got pinned.
Yeah, it's a painful procedure, but... Okay, so you gave us a teaser picture of some thing you've been working on there that looked quite interesting. Is that what you want to talk about here, or what do you have?
Yep. I want to show off my two little old babies here.
Wow, they were cute. They are very neat. I was going to say, just before you brought this on, I was going to mention to Mario that I really liked his PVC structure. That was the same joints as this pretty much, and tubing. I think it's even the same size. And he had a little motor enclosed in it and so on. So go ahead. Yeah, it's very clean looking structure.
So I came across Carrie Ellis's YouTube channel this week, and I was watching videos from the Peru group and Jonathan Vivek and a few others that she was interviewing. And I discovered the new car mag grav that they were doing down in Peru. So I decided to make a couple.
Okay, those this is way too big for the ones we're making in Peru.
So I got.
Is this the home? Maybe this is the home version of the car version, or this could be the semi-trailer version of the car version.
Yeah, well.
So tell us more about it.
I was going to show some pictures here if I can.
Oh, okay.
Where'd it go?
So, John, you're in on this, I guess. As far as the ones in Peru, are you working with them, those guys, a bit, or you know
yeah, I'm
what
working
they're doing?
directly with Dave down in Peru, and
Okay.
This was originally a design that came out of the Philippines from the Innovation Center of the Philippines, because the typical car mag grav, if anything in there goes wrong, it's going to cause huge problems with your car. It works, but it's dangerous in that respect because you've got essentially the potential of a direct short circuit with really heavy wires on your battery.
Yeah.
Also causing some issues with the electric cars, Tesla's, RAV4 EVs, the fully electric cars. So the folks in the Philippines grabbed onto that, and they came up with a new design, which is two completely separate maggrav coil layers, and they're not connected together. So there's no possibility of a short circuit in your car. And Dave has been testing them in Peru and having really good results.
So how does that work?
So
it's separate. Can you give us more information about that once we have a look at these?
Look at what he's built.
Okay.
Like that right there, what I'm looking at, that's almost a complete system. The only thing it's missing is a GANS ball. Now, I need you to go over how you wired it. It looks like your loose wire from the maggrav coil is just coiled into the center, correct?
That's right. I didn't know what to do with it, so I figured, let's make a coil out of it.
And it looks like the end is terminated properly. Yeah, that should work. Just put a GANS ball in the center, just like the maggravs, and you're basically done.
So would you have two GANS balls, one in each coil?
Right now, Dave is using. He uses little bottles, little medical bottles, sample bottles. But he's looking at a system to use one single a bottle of GANS within both coils, and we're going to test that in the next couple of weeks.
I got my things all glued together now. Do you think it'll work without the GANS ball?
It might. I would think if it does work, it's probably going to be not as efficient. Maybe limited use. But they're getting almost an immediate 25% increase in their gas mileage down in Peru. And they've
Okay, well, I
noticed
could probably drill a hole in them.
the folks that are using them. One of the fellas, his. Let me see if I get this right. He's part of the MIP Peru slash Keshe Foundation Peru group, and his sister has a cartage company, and he noticed immediately that all of his vehicles that the system is on are running so much better, and they reported, like I said, they reported a 25% increase right away.
And are they putting the CO2 in the gas tanks right away too?
No, I asked Dave to do these tests one at a time. Put one device on and run it for a couple of weeks. Record the results, then add, because he wants to do the CO2 in the tank. He also wants to add nano-coated coils to each spark plug. And he was going to do that all at once. And I just said, Dave, slow down, one step at a time. Let's see what actually does the job.
Okay. I've never seen anyone put the coils on the spark plugs, so
yeah,
that would maybe you can tell us about that once you get some feedback from them down there.
Yeah, and Carrie hasn't released the information yet, but one thing that she's working with is she's building herself one of the wireless generators, and she's just putting simple nano-coated wire in strategic places on her car as receivers for that the wireless plasma generator's output. And we're going to do a test, a fairly long-term test. She's going to be doing a long trip in the next little while, and we're going to see if we can do it a really simple way. So you just have a generator in your car. Doesn't have to be wired to anything. It's the little triangle wireless device, which makes a plasma field. And then anywhere you want to infuse plasma into your system, you just put a little nano-coated coil antenna.
Neat.
Yep, but that looks really good. You had two of them there, so that's two separate.
Yeah, one I did just with the ABS test caps, a thin plastic, and it's pretty thin. It's sort of without the frame around it. I don't think I'd want to build it with the test caps. And the other one had the pressure caps, PVC pressure caps, and they're nice and solid. You don't need the frame around it. I put the frame around it because I'm nano-coating the inside, and I'm going to put CH3 GaNs in there, and that'll give me some additional fields, maybe make it stronger or whatever. So,
okay.
So that's.
And it looks really cool too.
The other thing about when you put the frame on, there's little slots in here. You can tie wrap this thing under the hood of the car, nice and solid. It's easy to make the mount. So,
yeah. And the wonderful thing about this system, the thing that's really messing people up when they look at it, is the coils are not connected together. You've only got one wire from one coil going to the positive and one wire from one coil going to the negative, and they're just basically essentially antennas.
Yeah, so that's what I really liked about this, because I had a IQ6 in my truck, and it's plugged in the cigarette lighter, but the darn thing would drain the battery if I didn't start the car in 3 days.
Right.
And then the battery got drained about 4 times, and now my battery's no good.
Ooh, ouch. Is this going on a diesel or a gas?
Gas.
Okay. We have another lady she's building a system right now, and she's got an older Mercedes 300D. And I suggested for the diesel, because there's no electrical in the engine per se, that the negative terminal, the ground terminal, go directly to the intake manifold rather than the battery. That's something you might want to try too with your truck. Is get the plasma into the moving parts, not into the electrical system.
That makes sense to me. I was wondering about that, and it seemed to be that you want to turn the entire block, that whole block of iron, that we call the motor, into a plasmatic entity, basically. You might even want to isolate the motor from the chassis and normally they're grounded together. There might be a way of creating a separate system.
If you isolate your engine, you're going to have electrical problems in your car.
Well,
They're not designed for that at all.
Well,
Okay.
eventually you won't need the electrical system of the car, hopefully, and that'll be part of that. Might actually be a way of doing that would be to bypass that ground connection from the engine to the frame, and making the engine totally sort of in the same way that tools and so on are double insulated these days. The motor would be sort of double insulated in its own plasmatic
If
environment.
I remember what Mr. Keshe said about the test car they had in Belgium before the bad boys confiscated it, which is seizing without clear lawful authority, by the way. Um, he had no engine, no transmission, no drive shaft, and no fuel tank. And he had the plasma generator connected directly to the wheels, if I recall correctly. So this is where I'm basing the idea of getting the plasma flow through the moving parts. Now, if you've
Okay.
got an
Mm-hmm.
engine and you're going to run an engine, you may as well run the plasma through the engine for now until we can move past that. But
Mm-hmm.
I don't think there's too many people out there that are going to rip an engine out and stick a plasma commutator on the end of the transmission just yet.
I'm certainly tempted with my old truck, but we're not quite there yet, as you say, to provide 200 horsepower worth of plasma power to the crankshaft, to the drive shaft.
Okay. I got a fairly thick braided cable going from the engine block to the frame, and I was tying into that cable instead of going right straight to the engine block. I figured that should work just as well.
Well, it will work. Eventually, the plasma will infuse the entire car. So it really doesn't matter where you hook it up. But if you put it in the cigarette lighter, it's going to be really slow to nano coat your system.
Yep.
If you have a good solid connection on your engine, it's going to nano coat that, and the plasma is going to infuse your engine really fast because there's a lot of the engine components that are already nano coated to some extent. So you're going to have, any material that's been hardened, your inside of your combustion chamber where the explosions happen, that's all nano coated. Your valves, anything that gets really hot is going to have some degree of nano coating already. So you should have, if you put it on the engine block itself, you should have almost immediate results.
Okay. And just to clarify, the negative wire, the one that attaches to the inner gravitational coil, the input, that goes to the negative on the battery or goes to the
Yes.
engine block?
Yeah, gravitational goes to your negative potential.
Okay. And then the magnetic coil goes to the positive.
Positive potential, yeah.
Okay.
Somebody did have an interesting question about that. I just read, I forget who mentioned it, but that when the car's running, the alternator is charging the battery, so the flow is the charge is actually going in the other direction against the normal output from the battery from the alternator. I'm wondering how that might affect things.
The electrons are still moving from negative to positive. Now it's kind of like if you've got a river flowing down, flowing down the side of a hill, and you induce a wave in that river. Yeah, the wave is going to go back up, but your flow is still going from negative to positive constantly.
Not if it's charging the battery. You have a flow going into the battery that's greater than the output from the battery in order to charge it. If your battery's at, say, 11 volts, then you need to charge it up to 12.5 volts or something. You have to put energy in that's a greater voltage in order to charge it. So the voltage potential is the opposite direction.
Well, the voltage is just pressure, Rick. It's like water pressure in a pipe.
Yeah, and it's like using the water pressure from your pipe to water your lawn and then pushing the water backwards to repressurize it would be equivalent to repressurizing, or basically it'd be more like I don't know, running a motor with the water and then using the motor to make it into a pump and push it backwards and pressurize a tank or something, and then it flows back out again. So
Yeah, I
the
beg to
batteries,
differ. Friendly disagreement, because you're not reverse biasing that battery. You're not putting you're not putting energy into the negative pole. All you're doing is you're increasing the flow, the pressure that runs through it, which resets the ionization within the plates of the battery and your electrolyte.
well, your current flows in the opposite direction. That's what I'm trying to say. And that's, you take an ammeter, which measures current, you put it on the cable, and while your battery's draining, you see the ammeter goes one way, and while it's charging, the ammeter goes the other way. So the current flow, the net flow is either one way or the other way, depending on if the battery's discharging or charging or just
Yeah.
neutral.
Yeah, but with the maggrav, we're not looking at that. We're looking at the
Right.
actual atomic potential, which is always negative to positive.
Could I ask something?
Sure.
Mark,
Surely. Hi,
hi,
Mark.
everybody Mark from Detroit.
Do you want
Which
to?
way would the power be coming out of an alternator going into the battery? Where would, like an alternator, it's making power, so there has to be an output of that alternator. Where does that power go to? Does
Well,
it
it
go
hooks
to a
up close to.
capacitor or to the battery directly, or does it go
It goes to
to
the
the negative?
battery more or less directly through in a modern system. It attaches close to where the battery terminal is, or onto the battery terminal.
Yeah, I mean
What's
it's
what's
like
that?
the output of your alternator kind of goes. If you think of it like plumbing, your output of your alternator is a pump. The output of that pump, basically the positive lead, which is, because you think about the flow, that's the direction everything's going to be going in. The positive lead goes out to the battery and then branches to everywhere. It's like having just a big manifold on your water system that feeds your whole house. And when you fire up the alternator, you increase the pressure in your water system. It's essentially what's going on. I mean, it can be a little more complicated, but I don't think you really need to think of it any more detailed than that.
Yeah, and the battery's like a big reservoir tank, basically, and you raise
Yeah,
the level in the
it's like
reservoir when you fill
the
it
little
up.
blue pressure tank you'd have in your basement next to your water pump,
Right,
which
similar to that.
water pressure up when the
Hmm.
pump's
What
off.
what about the voltage regulator?
And that would be like a pressure regulator in the tank. The voltage. Think of voltage like pressure in water, because it is. It's the electrical pressure. You can have high voltage and no flow. You can still have that high potential, the difference between positive and negative, that pressure, but no flow through the system. But you can't have flow without a little bit of pressure. So you can't have current without voltage, but you can have voltage without current. Does that make sense to everybody?
And the voltage regulator, back to the question there, it's most alternators have a voltage regulator built into them. They only have a single output in modern regulators, or modern alternators. But in the old style alternators, they would have a separate voltage regulator built onto the firewall or other places, and you would have
Yeah.
wires coming from that go to the battery. Lee,
Yeah.
you're
And then
patiently waiting there
with a,
with holding your
oh, go
baby.
ahead.
He's nursing his baby and wants to show it off, I think.
Well, I figured it's better than just looking at my face.
Well, it is nice.
Uh,
I really do like that enclosure, or that it's like a what do you got, a roll cage around it almost, and some of
yeah,
these.
I've fallen in love with using PVC pipes here.
I really like it. I think I'm going to do the same thing, something similar. It looks like you could throw it against a wall and it would still just bounce back and keep on working, or a rock could bounce off and it would. It seems like it would be sturdy inside an engine compartment, for example.
Oh yeah, it's really sturdy.
Yeah.
uh, John, I use 16 gauge wire for my coils in these things. What are they using in Peru? Are they going
14.
smaller?
14.
14? Why
But
14?
you're not,
It's
well,
smaller.
with the new system, with these two separate coils, there's no electrical flow through the coils. So
Yeah.
you could make them out of 30 gauge wire. It doesn't matter. I think at the recent discussions that have come up using the difference between stranded and solid wire in some of these systems, brought me to the conclusion that surface area matters. The more surface area of nano coating you have, the easier or the less problems you're going to have with your plasma flow. Because if a little bit gets damaged, it doesn't matter. There's lots of space for it to go through. So if you're really good at nano coating and your system is very carefully controlled and very perfect, you could probably go to a hair thin wire, and this thing is still going to do its job.
Okay, what I gansed my coils with CH3 on one coil and CO2 on the other coil. What?
Inner and outer, or end to end?
Well, there's two separate coils. I use two different ganses.
Oh, okay.
Any comments on that? What?
I would have done it coil to coil, not end to end. I would have put the heavy GANs on your gravitational and the lighter GANs on your magnetical coil. But who knows? Try it and see.
Okay. And I had another question. I forget what it was.
I have a question.
For the Gantz balls, or are they just using the composite Gantz, or?
Yeah, Dave's using basically the same GANs he's using in his home systems.
Okay.
And by composite GANs, just so everybody knows, you mean the CO2 GANs and the copper oxide GANs and CH3 GANs and maybe zinc oxide as well. Is that the basic combo? Yeah,
and I think Dave is putting a couple of drops of silver in there, and but that's essentially, it's the big three. Typically more or less equal quantities, so you're getting kind of a weird brown sort of an output color, not a blue. But I don't think that ratios matter that much, as long as you're in the ballpark somewhere.
And where's the information available about building this basic unit?
We haven't got drawings out yet, but it's so simple. It's a single flat maggrav coil, gravitational to negative. You have a second single flat maggrav coil layer with gravitational to positive or magnetical to positive. Put a GANS ball in the middle and seal it up.
By single coil, you mean one single coil within a coil? Is that what you mean?
Yeah, a single layer.
Right. Okay.
Good. I use coils, loops, and layers just to try to keep it consistent all the time.
Right. I just want to clarify things as we go along. Cause a lot of people are just tuning in. They don't have a clue what GANS is or anything, and if we start talking about stuff, they might actually try it, and it'd be good so we can clarify for them, so they won't ask me later, did they mean this or did they mean that, and have to communicate that and so on.
Yeah, each side is a single.
Let me get that lined up.
Each side is a single maggrav coil set. And the one side, your gravitational, which is your inside coil, goes to the negative. On the other side, the magnetical, which is the outside, goes to the positive. The other wire on each layer, just control it. Terminate the end, fold the end back on itself, so any plasma that goes through that gets fed back into the system, and seal it up so it can't get damaged.
And to be clear, both coils are hooked up in like parallel, basically, to the positive, negative to negative on that?
They're not connected together at all.
Okay, what's connected with the wire that goes in?
In what?
Into the unit. Is there any, the wire, the positive and negative that goes into the unit, what does that hook to?
The negative wire that comes from the battery hooks to the one side of it on the gravitational coil, the inner coil.
On both?
The wire on that coil, it just terminate it. Don't hook it up to anything. And the other side is the opposite. It comes from positive, goes to the magnetical coil, and the gravitational end, terminate it, don't hook it to anything.
I see. So the two coils are both independent, nothing's hooked together, basically.
That's right. And there's as long as it stays,
as long as the hot glue holds, everything's
drop
good.
A house on it, yeah, it's going to fail. But as long as you keep it with, without any mechanical damage, vibration problems, anything like that, There is no possibility of a short circuit. It
Right
cannot drain
on.
your battery.
Interesting. Okay. And the distance between the coils, do you think that's a critical measurement in terms of like if it was a capacitor arrangement, the distance between the plates would be critical or whatever?
Probably has an effect. Dave's systems are a centimeter or so larger than he's doing with his MagGrav home systems. So they're a little bit wider apart. But again, we're going to have to do, 500 units, each one spaced an extra 2 millimeters on 500 different vehicles to find out if there's a difference. But I would
Yes.
think, yeah,
Well,
you want to keep them, I'd follow the diameter of your inner coil spacing sort of thinking. I think that would be safe and prudent.
hmm now with this double coil arrangement, is there any indication how the fields might look or be? I mean, you have one coil above the other one essentially, and normally if they were double coils with the two orientations, then that would be more of a spherical field. But if the coils are above each other, the way I understand it, it's more of a vortex
A
or
toroid. A
toroid.
toroid. Yeah.
Toroidal
Yeah,
field.
well, with the toroid, the way Lee has his loose wire terminated, it's right in the center of that toroid, which is the maximum strength of the field. So I got a feeling that his is going to be very effective.
Yeah, it looks really cool. Maybe the GANS ball could be glued onto that center part of the wire almost and be suspended between the two curly wires
Hmm.
in the middle.
Yeah,
I'm gonna
that.
I'm gonna
Go
drill a
ahead.
hole in the top cap and then put the ping pong ball or whatever in there, so it'll be
Okay. If you
right
make
on
if you make another set, Lee, try it with a single ball right between the two coils,
Right, that's what I was
the.
thinking. Yeah, and then have
and because that's
your curly coils could sort of one could stick down a bit, one could stick up a bit, and hold the ping pong ball in the middle, perhaps.
yeah.
Yeah, I can instead of keeping the coils tight to the outside of the caps, I can put the coils close to the middle and have that curly Q at the end of the cap and connections and stuff at the end of the cap and the coils more towards the center.
Yeah,
Yeah,
and
that
that
sounds
that
interesting.
should theoretically that should take advantage of that extremely strong tube of plasma energy that's running up the center of that toroid.
Yeah. Okay.
So I don't know. Again, this is because we don't have any way to measure. We don't have any empirical data on this. It's all kind of intuitive. All we can do is try different iterations and see what differences we see.
Yeah, and there are people that'll be coming on board with fleets of vehicles that will want to try these these devices, and they'll be able to make that 2 millimeter difference and try 10 vehicles with the 2 millimeters and 4 and 6 and 8. And if you got a couple thousand vehicles, then you can do that fine adjustment. And if you're doing a fleet of vehicles, it's easy to keep tracking them. You're already tracking the mileage and tracking all the ins and outs of the maintenance and so on. So it'd be a great way to begin more testing on this. What do you got there, Lee? You're holding something. I got to see what you have there.
I got a question. I got a coil of extension cord stranded wire, basically 14 gauge stranded wire, and I want to pre-nano coat that wire to use in my projects. Do I just plug it into a MagGrav with say a LED light on it or something and let it sit there for a month, or how do you plasma nano coat wire?
I
How
tell
long a
you
wire?
how long a wire, he said.
100 feet.
All in one length? You
Um,
want to nano coat the whole thing?
And then I've got nano coated wire to use in my projects.
So you
Like
want
right
to, I see.
right now this isn't nano coated, so it'll nano coat itself with some time, but it would be better if I had that nano coated to start with.
Right, I see.
um, Basically, all you have to do is make it a plasma conduit, and it will nanocoat.
I tell you what,
However you want. I mean, this one here, this is I'm nanocoating these wires for my wireless generator. These are the connecting wires between the little bottles of stuff,
neat.
and that's
And you stuck them in a, hold it up a little higher so it's in a bottle and with
well,
caustic in the
this is
bottom.
so it doesn't roll away.
Yeah,
That's all.
it's in a bottle. It's got caustic in the bottom. Is that what that is?
Yeah,
Or,
I just took an awl, little punch awl, and punched
yeah,
16 holes in the, or yeah, 3, 6, 18 holes in the top of this.
yeah,
Ripped about
yeah,
a half an inch off the end of each wire, stuck
yeah.
it through the hole, and the holes it fits really tight.
And
These
the insulation goes right into the bottle then, right? The insulation on the wire?
yeah, it just goes in a little bit, and then
Yeah.
there's some bare wire hanging out on the bottom.
Oh, geez, I haven't spotlighted you. Just a minute. Let me get you on there so the live stream people can see. They weren't able to see it. There we go. Sorry about that. So, yes, this would be the way I would suggest. I was going to mention that I tried something with similar wires. Is that a transparent insulation on those wires, John?
Yeah, this is
Yeah,
speaker. This is that
yeah,
transparent
yeah.
clear speaker lead,
Yeah,
and I used
exactly.
copper and
I tried about a meter length, and I hooked it up to my vacuum pump on one end, and I put it
oh,
in caustic on the other end, thinking I would pull the caustic through the gradually pull it through the wire, and that would nanocoat it. And then I had another one as a test wire um, in the caustic, but not with the vacuum pulling on it. So I figured the one with the vacuum pulling on it would pull the caustic through faster and nanocoat faster. But it didn't. And it turns out it needs to have that air space in there in order to, combine with the oxygen and so on. Just putting pure caustic through just doesn't work. It doesn't make it as effective. It's the vapors that do the trick. And this is a perfect system you have here with just pulling off the vapors. You don't even need the liquids to touch the cables at all.
yeah. I don't know how well you can see it, but this one wire, there's about an inch at the end of that wire that hasn't nanocoated yet.
Mm-hmm.
I don't know if you can see it on camera. It's pretty clear when I'm looking at
Yeah,
it.
yeah.
There's 3 or 4 of these that are all black right to the end already. This one's one of them here.
And how long has that been again?
Oh, about 4 days.
Yeah, that's pretty good.
And I stuck it in there, put the caustic in, just gave it a shake, and it's been sitting on my shelf.
Yeah.
First day, it didn't do a whole lot, and then I noticed the second day, it once it starts going, it goes really fast.
Yeah, I'm wondering if that was 100, 100 feet long or, whatever, 20, 30, 40, 50 meters or something. What's the rate going to be, I wonder? Is it going to be like a few inches a day through the whole cable? Do you think it'll accelerate at some point and just start doing the whole thing?
Well, I noticed with this, the first day, it just the ends where I'd stripped the insulation that were inside the bottle turned black.
Uh-huh.
The second day, it just passed the bottle. The third day, it was almost at the end.
Ah,
So
yeah.
yeah, it is. I
I
think the
remember
travel
something like
of the
that
next
as well. Yeah.
100 feet. I would think, Lee, to do 100 feet in this method would probably take maybe a month.
Yeah, that's sort of what I was thinking, but that's why I was wondering how to do it with plasma energy instead. I thought that might be faster. So,
Yeah.
so I was thinking of buying, a couple of spools of 18 gauge stranded wire, and then I got the 14 gauge from the extension cord, and then I wanted to get it all nano coated up ahead of time so it's ready to use.
Yeah. Don, he's not in the group here tonight. I don't think he comes in this group. He's in the Skype room. He's got a double maggrav system that he's been experimenting with, and he's got 2 coils of wire wired into his maggrav system to see if it will do exactly what you're thinking. So maybe by next week we should have some results from that. I might be able to let you know about that.
Okay.
The simplest, easiest way to do it is build your system, get everything all mocked up. So you've got your wire lengths, everything, you know how long everything is, and then take it apart, nanocoat everything, reassemble it.
That's what I've been doing. I just was looking for a faster way, shortcut.
Yeah. Well, the point is, once you have a piece of wire nanocoated, you don't want to cut it.
Why?
You want that nano coating wrapped right around the end of that wire. If you cut it, you're going to introduce problems. You're going to have to re-nano coat sections. Anywhere where you bend the wire, anywhere where you've twisted it together, you're damaging that nano coating, and you're going to have to go back and repair that damage. Remember, the nano coating is fragile, very, very fragile.
That's a really good point.
The factory in Italy, we had a couple of thousand coil sets that were just garbage because the guys who were working didn't understand, and they just took the coil sets after nano coating and dumped them on a bench in a big pile, and that completely ruined the nano coating on all of these coils. Treat them like glass, like the most fragile thing in the world.
So if you make a wire twist after you've nano coated, you got to brush some caustic on it and try and your nano coat back. Is that correct?
That's right.
Yeah,
That's
a
right.
little bit of a weak spray caustic will tend to do it. Just a light, very light spray, it seems, and it just it'll tend to heal itself anyway, but it'll take longer without a little bit of spray. So
yeah, one thing that's true, Rick. If you've got a plasma flow, but if the damage is caused, if it's an electrical device like a maggrav, something like that, not a purely plasma system. If you've got a matter-to-matter electrical connection, it won't heal because you don't have any plasma flow. You've got electrical flow.
right, yeah, but generally there'll be some resistance there with if it was nano coated.
Yeah, because some of the maggravs we've had issues with, we just asked them just unplug it, let it sit for a week, and plug it back in, and they work fine after that.
Right. Yeah.
They just never repair, and the only thing that we can come up with as far as tech goes is there's a matter-to-matter electrical connection there, which is not allowing the plasma.
It might have even welded itself together at that point, and that's why it won't heal itself.
Yeah.
Well, I'm jumping in here.
Oh, jumpity Jew! It's
Bernie
where'd you
last
go?
week, and Douglas was talking about this particular thing, and Bernie was using his vortex type of system where he had the 4 bottles with the single coils inside, and then the 3 coils on the outside. And he was saying he was getting some nano coating on the wires using that system itself.
That's a purely plasma generator. It creates a massive field. Like I mentioned, I don't know if you were here at the beginning of the show, but Carrie Ellis, she's going on a road trip. She's building one of those devices, and we're going to do a test with just that device and then little nano-coated receiver antennas spaced around her car to see if that'll pick up the plasma energy and infuse it into her vehicle. Which is,
so that would
a
be
step into the wireless, right? We're doing test into the wireless.
I think, Lee, you had started making one of those systems, didn't you, Lee?
Yeah, I got a few of them here, 3 of them. But I got to change I just made some new lead GANs, and I'm going to change out the GANs I got in the middle may not be lead. So
could you give us a little closer picture of that, Lee? Could you hold that up a little closer so we could see it better, Lee?
Yeah, let me switch the camera again.
Oh,
okay. There is a drawing on the net, or actually 2 drawings on the net for that system, made by a young, I think it's Miriam. I can't remember specific. I have to look on. It's on the drawing. But the first drawing is incorrect. It's wired wrong. The second drawing that he released, it's wired correctly. And Mr. Keshe looked at the drawing, looked at the first one, and said that the location of the GANs was incorrect. So I suggested to Carrie, and I'm going to suggest to everybody who's listening, don't just copy the drawing because it's probably not correct, whichever one you have. Look at the wiring, look at the way it's connected together. Think about the flow of the plasma. Plasma goes from the heavier to the lighter, always. And you want to make sure that you have a nice, smooth vortex within the wiring and within your plasma flow on that drawing.
There's one thing on the pictures that you don't see. Your 4th bottle in the center. It's the way he turns the wire. If he turns it clockwise for the main 3, he turns the 4th one in the center the opposite way. He would turn it counterclockwise.
Yeah, the 3 maggrav coils and the 3 pickup coils on the outside are all the standard maggrav windings. Run your drill in reverse as the coil builds away from you. The center one is the opposite.
So how about you, Lee? Did you catch that when you were making yours?
Yeah, one of them's turned clockwise, the rest are all counterclockwise.
Okay.
So, and I
And
left.
I'm pretty sure that is on the drawing. Let me see if I can find that drawing. It's been on the net, so it's public domain, Rick. It shouldn't be an issue.
I just drip cancel down on my keyboard.
Okay. So John's looking for his that document, I guess, right?
Yeah, I'm gonna see if I should have it in here somewhere.
Have you got yours finished, John?
I had some issues with my nano coating. A couple of the coils didn't finish, so it's just sitting in the nano bath now, waiting for the coating to build on the last couple of coils, couple of bits of the coils. Oh, come on, where is it?
So a single bare copper wire does not nano coat if it had a shield around it as easy as the stranded wire, I take it.
Actually, the stranded wire coats really fast.
Yeah,
I
the
did
solid
probably
one, the solid
5 inches
stuff.
in a day.
Solid stuff's very difficult to nano coat inside the insulation. It takes a long time.
Oh, okay.
Is that the one you're looking for, John?
Which
Or did my
No, that was the correction that Mr. Keshe made, I think. But no, the one I'm looking for, it's just an actual like an engineering drawing that was put out by the individual. It actually shows where to put the wire, how to hook this thing together, because that doesn't really show how to wire it. You guys better go on. It might take me a while to find this.
okay.
I've got way too many hard drives.
Well, Lee, did you do the 75%? Because you're always working and always doing that stuff. Did you do the 75% system that you were talking about last week?
What do you mean 75% system?
That was the Armin and you guys were talking about how to set it up, and John drew the drawing of it where you use the two Magyar systems and hook them together and get your you're able to improve the amount of electricity you get from it.
Yeah, 70%.
That's what's in the 5-gallon bucket here on my table. That's the next thing I wanted to show you.
Okay. Thanks for the segue there.
Are you ready to show it?
Well, we'll just finish this. Is that the one, John?
What are you?
There it is. There it is. Okay, that's version 2. Okay, I think that's the one that's wired backwards.
Wired backwards. No wonder mine don't work.
She came up with the first drawing. I assume it's a she. I may be wrong, but a week afterwards mentioned, "Oh, I'm sorry, I wired this backwards. It actually goes the other direction." So, and this one, let me think. That goes gravitational. I mean, it looks like it should work, but I've got both versions. I've labeled mine version 2 and 2.1.
Yeah, find yours, and then I'll have to do a screen copy and so I got the right one.
Yeah, I sent it to Carrie. I might have it in Skype here. Hang on a sec. Actually, don't hang on. Keep going. I'll be here.
Okay, so what I did is I've built this double mag grav like Armin was saying, and it fits in this 5-gallon bucket here nicely.
Wow.
It's not, I haven't finished wiring it yet, so I was working on that today. So.
Wow, that's really cool. The whole thing fits in a bucket.
When you're ready.
Okay, I got it. I found it. There we go. Yeah, this is the I labeled it 2.1. This was the corrected version. If you notice, this runs in the opposite direction from the one that you've built. And the idea is to keep your coil winding and your plasma vortex flow all the same. Now, whether or not the GANs is correct, we're going to have to go over that. So we've got, what do we got? This is the heaviest, copper oxide. That's CO2, so the flow is going to there. Yeah, it looks like this one is the GANs is correct in this one. But your lead's in the center. You've got a coil in the lead, which is clockwise wound. The output of that coil goes to the gravitational side of each of the maggrav coils. And then your plasma or your GANs reservoirs with the coils wound clockwise, they go to the magnetical side of the opposite coil. So if you look at this, if you look at the way this is wound, if you think about the plasma flow, the plasma is going to spin like crazy in this system. And that's the whole point. We want a dynamic plasma out of this device. And so far, everybody that's built these, they're amazed at how powerful they are. I'm really wanting to get my nano coating right so that I can get mine built and test it for myself.
Isn't the red wire going to the magnetical there, not gravitational, like you said?
Oh, sorry. Yeah, red wires to magnetical, the outside.
Yeah.
The inner one is always gravitational. The outside is always magnetical.
I have a question about the flow here. It seems to me, I know Mr. Keshe turned it around, but the original, that first drawing you had, the top was CuO, and then the lower left would have been the CO2, and then the CH3 to the right. I would think that would cause a counterclockwise flow. But
this one we're looking at is a counterclockwise flow, because this is the heavy GANs, and it's going to want to go towards this GANs, right? So, and also the wiring is also in the same direction here. And I think that's where Mr. Keshe made the correction.
But you're going clockwise there, from the CuO to the CO2.
Okay.
And then so you have a clockwise flow here.
Unless you're looking at it from underneath.
Yeah, but okay, but
Well,
then you also have
what about wouldn't the CH3 be lighter than the CO2?
Yeah.
So wouldn't it flow that way? Wouldn't it tend to flow that way more easy than toward the CO2?
Okay, which
from
means
the
you would have
CuO?
water flows in there, which could be. I can't say that that's not correct. We know that the magnetical and gravitational are counterflowing fields, so perhaps that is actually beneficial, where you have both interactions going in both directions at the same time.
Yeah, I wonder about that. Now, but between the CO2 and the CH3, then the CO2 should give to the CH3, right? It should the CO2 would be the heavier, CH3 would be the lighter. So it would flow from CO2 to CH3, which would be clockwise.
Yeah.
So
Yeah,
it's a
and
little.
I think what Mr. Keshe, when like the original way I had it in my head would have been the CUO up on top. So the CUO's there, then the CaO2 is on the left lower, and then CH3 is there, so that the CUO is feeding the. Oh, I see. Wait a minute. No, I got that backwards. But I think Mr. Keshe had two hemispheres, is what he had when he drew this out and when he straightened it out on one of the other drawings, so that you have a counterflow. You have the CH3 going to the CuO and the CO2 going to the CH3. So here you have that clockwise or counterclockwise. And then the CO2 is going back to the CuO, and at the same time, I don't know, he had actually like two hemispheres in there somehow, going out on one side this way and the other side the other way.
Yeah, I mean, there's going to be a number of different interactions within this, because you're going to have the copper and the CO2 both feeding the CH3. So I think we need to kind of generalize a little bit with this in order to visualize it correctly. If we go into too much detail, it's just going to get really weird right now.
Well, it's supposed the hard wiring also is definitely conducting a flow. So there is also drag the other fields, I suppose, or whatever.
Yeah,
so,
and something that came up, both Vernie mentioned it and a number of other people mentioned it, is everything, all of the wires, everything need to be pre-nano coated. Don't use any matter state in this at all if you can avoid it. Otherwise, it's just not going to start up for you.
Well, I have to disagree with you, John, because Vernie did not nano coat his system, and it nano coated itself. Some of them. So I may be wrong, but that's what I understood.
His could have also been sitting on a shelf for 5 months too.
Yeah, he could have other things that are around it that cause it to nano coat. When you got so many things around it and you haven't isolated it, then it's tough to figure out what you've really accomplished.
Mm-hmm.
Yeah, it's a simple matter to make your three maggrav coils, wire them together, then nano coat it. Make make your pickup coils, your 4 pickup coils, and nano coat them. As I just showed on the camera, the wires that I had in the bottle are the wires I'm using to actually connect this all together. And I strongly suggest pre-nano coat everything, and try to assemble as far as possible before you nano coat. So you are manipulating the
that's what I would do. I'd make certain everything is nano coated when I'm done, I'm done.
Yeah.
And so I have I'm in the process of doing some nano coating. I have different sizes of these, different sizes. I've got a quart bottle system. I've got some smaller ones. I got some 15 milliliters. So I wanted a variety. In fact, I've been toying with using my 33-gallon barrels to see what I can do with it, and using a heavier gauged coil.
I'd be very, very interested in seeing your results, because I'm of the opinion that size doesn't matter.
Yeah, that's what I understand too, but it doesn't help unless you actually test it.
That's right.
In the end of the, and so it still has to be, if a person's got the gall to test it, they should do it.
Yeah, I mean, if you've got the wherewithal to make one of these out of 5-gallon buckets and 4-gauge wire, do so. Try it. See what happens.
Yeah, right on.
Who knows? Maybe you'll get a plasma field that goes 200 miles instead of 300 feet. I can't really say. With the maggrav systems, what I've seen when I do the forensics on the systems that are non-functional and helping other people, the volume of GANs that's in those little balls is tiny. The ball is like a paintball. It's very small, and there's only maybe a fifth of it has GANs in it. It's just a little tiny pea-sized little ball of GANs in there.
Yes, I have some glass tubes that are extremely tiny. They're about, I don't know how many milliliters, but it's so small. I'm doing those as well with a slider. wire just because it's that theory. It's the size didn't matter. Why go to all that trouble? But if
Yep. I mean, Dave's maggrav systems down in Peru, he's using about 5 milliliters of GANs in each layer in his little bottles, and his systems work just fine. The commercial systems, they're using maybe 0.1 milliliters or even less, and they're working just fine. So I think it's the law of diminishing returns. If you go bigger, it's going to get to a point where it just doesn't matter anymore.
Okay, I think we have a question from Menachem on the chat here. Like he had a question before. You're able to GANs coat with insulation still on the wire. That's a question.
Not GANs coating, nano coating.
Right. I think there wasn't anything about GANs coating with the insulation. He wants to join the conversation. Go ahead and open your microphone there, or I can unmute you, Menachem, if you have a question there. Go ahead.
Yes, hello?
Hello, yes.
How are you today?
Good.
Good stuff. Great. Well, I would just correct, as John says, nano coat a wire with the insulation still on.
Right, that was
Yeah.
what we were discussing, yes. And his wires have insulation on them, and I've done the same thing, and we've...
Insulation inside of the bottle?
There's maybe a millimeter's worth of insulation in the bottle, and then there's about 5 millimeters of bare wire that I've stripped the insulation off that's actually in the plasma, in the vapor of the caustic.
So like the wires that Peter was talking about, using these thick wires, the 10 gauge stranded wires.
Yeah, basically
Right.
the same thing. You'd expose 5 millimeters, maybe a centimeter at the end of the wire, and stick it through a hole and have that exposed to the caustic environment. It will eventually work its way to the end of the wire. A long wire, 100-foot wire, 30 meters, is going to take a while.
Right, but it is possible to do through the insulation. That's amazing.
Yeah, you can watch the first part of the video. We discussed it for 20 minutes or so there with showing the different wires.
I wanted to clarify that because I was astounded. I wasn't sure, actually. Is that actually going through the insulation? You're saying that's possible. That's amazing.
Yeah, it goes right along the inside. It is
Yeah,
quite amazing. I was amazed the first time I saw it. I didn't believe that it could be done like that, but yeah.
It just grows down the copper right under the insulation.
Yeah.
It's actually kind of interesting to watch.
Yeah, I've seen wires turn black before from overheating, using 16 gauge extension cord and running way too many things on it in a tree planting camp, for example. The wires, extension cords come back, if they come back. They come back often fried, like black wires, and they don't conduct too well. They don't work so well in the matter level generators and the matter level devices that we use. And like commonly, if you were an electrician and saw a wire in a household that was black, your instant, pardon me?
Oh, sorry. No, I just, my everything froze up here for a sec.
Oh, I think
I had to leave for a minute, Rick, and I hate to jump in here, but we were talking about nano coating the wires with the shield on, with the coating on. You strip you strip some off of each end. Let me use my video. I hope I'm going to be okay. I'm on.
Yeah, do you have clothes on?
Okay.
Yeah. Okay. We'll show it then.
I'm never naked. So I just had a container like this, and I had wires that were the length of that. And so I put a little I put a little cold caustic in there, and I put my lid on it, and I just set it and left it. And I think it was about 2 weeks. I didn't have any need for it at the time. And so when I came back, it was completely nano coated because I stripped the shield off of it to see and so.
How long was that wire again?
It's as big as the cup.
As long as the cup, like just the short
Yeah,
pieces.
and so I had a bunch of them. I put them in there on
I
ends,
see.
on end,
So
and
the end was sticking into the caustic.
one end was sticking into the caustic. The
Was
other
was
was
it totally like was the insulation also sticking into the caustic or just the wire?
no, just the wire because
Okay, yeah, yeah.
I was going to,
I think that's the best way to do it.
well, it was just one way to do it.
I think that if the
Yeah.
whole wire, I think if the insulation is into the caustic, then it's probably not going to work as well. It needs to have that vapor gap there. The vapors go through the whole wire so readily compared to the liquid.
Yeah,
And
the other thing that I'm
Last
thinking
year,
about, the other
sorry,
thing,
sorry, go
sorry,
ahead.
the other thing I'm thinking about with the way you've done it is be careful with your insulation because the caustic environment it doesn't like a lot of stuff and it could possibly degrade your insulation really badly.
well, it it didn't, but I can see what you're saying. The only other thing I was concerned with is what kind of polarity I was going to get because both ends were stripped. Just one was sitting into the copper, but you still have fumes.
Mhm.
And so, but I figured it was,
Yeah, that's a good question. You would think that it would be similar to the fire process where when you heat from one end of the coil to the other, that will be inducing you're coaxing the plasma field to go in that direction is kind of the idea. So perhaps by putting in one end into the caustic vapor, it would start that end as similar to the fire coating process, and so therefore the plasma would want to flow toward the matter end that's sticking out of the caustic vapor. Interesting.
Excuse me, sir, Rick.
Mm-hmm.
Please may I ask another question?
Yeah, just a second. There was a comment from Mario there. Mario, did you have something else you want to say on that topic?
Yeah, last year I was nano-coating plastic a lot, and I took some coils that I made that I did not strip the plastic sheeting, and I stuck them in containers with the hot caustic. You know, I steamed it, and it nano-coated the copper right through. I noticed that, and it took it like 2 days. You know, but it was in the container, closed container with the steam. You know, so it wasn't in the caustic, but it nano-coated as fast as it nano-coated regular wire that was stripped.
Yeah, it's amazing. I would have never believed it unless I tried it myself and saw it from someone. So, okay, Menachem, you had a question, another question there, you said?
Oh, it was one or two questions. One thing on the subject that you're talking about right now, I wasn't sure if I understood. People were discussing ways of even Mr. Keshe was discussing ways how systems nano coat wires in the house. Maybe I didn't understand that. Or ways that a system, other ways of nano coating insulated wire by connecting it to a plasma system. Let's say for like the month or 2 months that it took to condition a house, something like that. So by putting, let's say, strands of wire in place to use that system to nano coat them and then take them out of the circuit again and just use them as nano coated cables to complete maybe another circuit. And the other question was
some people can have done that, but the thing is, it might take a couple of months more to properly nano coat.
Or maybe there is a way to do it in a quick time, you know, in a faster process to just connect a system that's designed specifically for that, like GAN's process of connecting a certain amount of current and amp to a cable.
Well, anywhere you have a plasma flow, you're going to wind up with nanomaterials forming. That's the nature of the beast. So if you're nano coating wires, what you want to do is supply a plasma source and give that plasma a reason to go to the other end of the wire. and it's going to nano coat. It's going to take as long as it takes. Now, a lot of guys, everybody's really hung up on doing this really fast. And what we're finding is people that are trying to go too fast are running into some serious problems. They're having issues. Things aren't working right.
Right, exactly. Could you
Patient-
address, John, yeah, you
Hmm.
had a question before, Menachem, in the chat here about
Yeah.
about the nano coating with fire, and it has
Right.
no GANs on
And
it.
another one, what you just said about winding coils counterclockwise, one specific, does all that stuff matter? When you say people don't get things right, if they don't do stuff right, would it matter if someone didn't wind the coil specifically the correct way, one coil and all the rest of them the other way? And if one person did it counterclockwise, all of them, and the other one, the opposite to someone else, and if a person just made a magrav and they didn't GANs code it, they just nano coded it. All those
You
kind of
can
things.
do all those kinds of things, and sometimes they'll work, and sometimes they won't. Sometimes you'll have only a 2% or 5% or 10% difference in your power. When if everything's working properly, it might be 20, 30, or more percent, and so on. So yes, it's like anything that's technical. If you do kind of a sloppy job of it, then it may or may not work out.
Yeah.
It may actually work out better. Some sloppy jobs may end up working better in this circumstance, because it's a lot of unknowns out there in this science. It's science, but it's also iffy in a lot of ways. We have to try things to see if it'll work, and then modify it a bit, change the variables, and try it. Like Mr. Keshe says, there's no real mistakes. There's just the learning experiences, and if something doesn't work, supposedly, he says, don't throw it away. It might be useful for some other aspect or some other part that we haven't used it for yet. So go ahead, John.
Yeah, one thing I've noticed, Manicum, teaching people how to make the health pens, I have seen absolutely perfect coils. I've also seen extremely rough coils. Spacing is all over the place. The diameters are all over the place. Both still work really, really good. As you add complexity to these systems, as you get more into the detail of the system, then yes, the perfection does matter to an extent. And with this new style generator, this wireless generator, what we're seeing is a mixture of clockwise and counterclockwise coils, which leads me to believe.
What? Looks like you made it. What about for a Tesla coil?
Sorry, I just realized my sound wasn't on the live stream there. I was just talking about the coils being perfectly wound on this particular coil set, but that in some coils, in fact most coils, you could have it as a more or less haphazard and lumpy, and it'll still work quite well as a solenoid or a magnetic field initiator. So yeah, it's funny about that.
And to address your question about the direction of the coils, when we look at this the new style plasma only reactor, the generator, which we had on the screen earlier, which is the beginning of the wireless system, we've got a mixture of coils. We've got both counterclockwise and clockwise coils. This leads me to understand that the counterclockwise coils are a magnetically biased. They are an expansion side biased configuration, where the clockwise coil is the contraction or the magnetic or the gravitationally biased coil. So if you have within the maggrav system specifically, if you have, say, one of your coils is wound backwards, you're going to wind up with an issue of interfering fields. Your field flows, you got one going one way, one going the other. They're going to be button heads all the time, and it's going to reduce the efficiency of your coils. If your connections are not the same as your coils, again, you're going to be adding that kind of a feedback, that resistance within the system. So yeah, direction does matter. But what came out when we were discussing this originally, before the blueprint sessions, the blueprint week, as long as they're all the same, that's what's most critical with this. I have a maggrav system that I wound, everything is clockwise. And I'm thinking that if I add that to a counterclockwise system, I'm going to have both a magnetical bias system and a gravitational bias system. I should have a massive flow between those two sets of coils.
I have to, if it's okay, I have to just mention that I have a rushing flow of thoughts right now. I have a ton of thoughts that I just got bottled up, and I wish I could share the stuff that is in my mind just a little bit. The thing you're saying right now, I'm just imagining the picture of a guy made a health system for himself, and he put his leg through it, and he gives a testimonial of how it helps to heal injuries, which I know a lot of people have. I've unfortunately managed a couple, and I know everyone can benefit from that kind of system. And he shows a coil that looks like maybe it's insulated with a heat shrink, or he's made like I don't know how many hundreds of turns in it. And that's another thing, like, would all that stuff matter? Again, like, he's made his own kind of spec design of a system. If I could show you another one, if I take...
Sorry, your sound just went up there. Hello?
Yes, hello?
Hello? Yeah, we lost your last sentence there.
Can you hear me there?
Yep. Yeah, we hear you now.
I can give another example.
Go ahead.
If I would take 6 coils and I overlap them in a stack, let's say in straight lines like a triangle. I take the 3 outer coils and I put a triangle of the gravitational coils, and then the 3 inner coils I can also put in a triangle stacked on top in a kind of opposite direction. So it's 6 points. And then I can put, let's say, my plasma GANs containers on each point. And then on the center, I can put, let's say, the rotating bidirectional. It goes in 2 different opposite field, the GANs gas plasma liquid, or whatever it is. You know, would it matter how someone designs it? Or
yes, it matters. It matters a lot. Yes, absolutely. Everything matters. But the thing about it is, like Mr. Keshe says, there's as many types of reactors or many types of systems as there are stars in the universe. And your mind can get filled with a million designs, and there's a million ways to do it. But the thing is, you have to actually do one yourself and create it and feel it and then modify it and feed it and work with it. Otherwise, yes, wait a minute, you have ideas, but we could go all night with a million ideas, because there's billions and billions and billions of ideas out there. But there's people that have built stuff, and they want to talk about the stuff they've actually built. So I would rather deal with the real life stuff if we can, and not get into too many ideas because
Same here.
we have to start visualizing what you're trying to visualize, but you need to visualize your reactor and create your reactor. We can help you with it, but we can't totally visualize it all together because we're too busy actually doing all this other stuff and so on. So I mean, you get excited and you want to, you know, you could go for a long time, I'm sure, with all these different ideas and so on, but it gets too hard to deal with, ethereal stuff. We need some physicality to sort of work through it, or a picture or some sort of diagram. You could do, we could work with some theoretical with the whiteboard and some diagrams or something perhaps. Otherwise, when you start talking about triangular combination here and this and that, and we can't even visualize what you're talking about because there's a million ways that, as soon as you say triangular combination, there's a million ways you can do just the triangular combination. There's a million ways you can do one single ball. At least a million ways, probably billions of one single ball without even a ball within a ball. So think about it. Try to come up with something that you want to do. Follow your passion on your reactor the way that you envision it. And this is everyone here that shows things has their own way of presenting it, their own way of putting their own stuff into it. It doesn't matter, you try to replicate. I've never seen anybody replicate exactly anything that came up from Keshe or anything, because we all tend to personalize it with our own ideas and, you know, a slightly different variation. It's very hard to do exact replications of this technology when it's hard to determine whether you've got 20,000 layers of copper oxide nano coating, or 30 or 40 or 80 or 20 or 5. How do you measure? You know, how do you tell? And a lot of that is sort of guesswork, but educated guesswork, and through testing and other means. As John mentioned earlier, when physicality meets physicality, that's different than the nano coating, and it could end up with melted wires or other short circuits and that kind of thing, unless you go plasma. So anyway, let's...
Can I come in? Can I come in a second?
Surely.
One thing about that, I think a simple way to put what you're just saying is it's more art than it is science. There's not a formula. It's how you want to put it together. So in that way,
in the same way as the music that you deal with so much, Mario, and others, when you compose a song, it's never an exact replication of somebody else's song, even if you're doing a cover of it. It's you put your stuff in it, your voice, your inflections, your different style, and so on. It can never be exactly the same, and it would be a shame if it was, really.
Yeah, and every time you play it, it's going to be different.
That's true, too. It should be. If you think it's the same every time, then you're missing the point, I guess.
There's only one Rolling Stone.
Sorry?
Only one Rolling Stone?
Yeah.
Think about that. There's only one Rolling Stone. We're all just one Rolling Stone.
Okay.
Can
I ask John a question? You were talking about before, just a few minutes ago, magnetical you're saying is counterclockwise and gravitational is clockwise. I always get that in my mind, the opposite direction. The clock faces towards you. When it's going clockwise, it should be spiraling outwards, where it's same thing with the direction of the coil. If it's going counterclockwise, it means the fields are going away from you. Now,
okay, there's a really easy way to think about this, and that is go get yourself a wood screw or a sheetrock screw, any standard thread. If you look at that standard thread, that is going to be considered counterclockwise. It would match the counterclockwise windings of the maggrav coils, which, from what's coming out lately, leads me to believe that that is on the expansive side of the equation, the magnetical side of the equation. So anything where you want to emit your plasma or emit electricity, you want an expansive type of system. You want a counterclockwise system. Anywhere where you want to collect plasma or draw in, you want the gravitational bias system. So you'd want a clockwise system, which would be a reverse thread.
Yeah, but I guess it depends on which way you're looking at it. I think it's in and out and direction of flow is the only, if get that clear. If it's going in one direction, if it's going away from you, it should be going clockwise or
Exactly.
counterclockwise rather. Sorry, no?
This question came up a lot, and a lot of people had a lot of trouble with it. And I use the analogy of look at your coil, hold your coil up and have it face away from you. Imagine you're an ant sitting on the wire and you're walking down the wire of the coil. If it's
Well, okay, well, hang on a second. Look at this picture on the screen.
Yep.
You notice how if you're looking at it facing from the left side, in that the left side is the output and the right side is the input, and those coils are going clockwise if you're facing them. And if you look at
looking at that drawing, I would say that would be a gravitationally biased system. That's going to draw in the plasma because the coils are going in the opposite direction of the ones we wind for the maggrav system.
Well, I tend to think of it like this. The red one, say that's the magnetical, that's going clockwise and it's going out the red. But the blue is the gravitational. So when you look at it from the left side, you're looking at it going in, going counterclockwise in the opposite direction.
Yeah, you can really overthink this. Trust me.
Well, I mean, it just, well, okay, I mean, is that okay that way, what I just said? The red one, when you're looking at it going, if you have magnetical, it's coming towards you. You always have both. So that when you're looking at the red one from the left side, inwards, it's actually coming towards you clockwise. See? But the blue one is the gravitational, so it's going away from you. So it's going from so the red is going from the right to the left, and the blue is going from the left to the right, the opposite direction. So looking at it from the left side, it's like a clock. The clock is the red fields coming towards you, and the blue is you're looking at the back side of the clock, which means the fields are going that way. So it's just the direction of the flow, not necessarily magnetical and gravitational. I mean, because turn that around, and it's the other way around.
Yeah, it's a good point.
The direction of the flow is magnetical or gravitational. I mean, that's the whole crux of the matter. And like I mentioned earlier, I look at this system, and I would say that as a system, that would be gravitationally biased. That would want to pull energy out of another system.
You mean pulling from the left to the right in that way?
No, pulling from the end of the test tube where the little black lumps are into the coils.
Okay, but if
that's right to the left. I mean left to right. Then, sorry, Rick.
Yeah, so left from the tip here. If you can see my little pointer here.
Right.
To the it's a good point that Mario brought up. Like normally if this was a magnetical coil and gravitational coil in our double coil setups or circular coils, then one would be attached to ground and one would be one negative and one positive, let's say, or one in and one out. So if that red one is the out, for example, then it's going let me see, can I get my annotation working here?
From right to left, so to speak. But then the blue, you would attach to the ground, to the out of to the ground would be going the opposite direction. So when you're looking at the flow is always going in the opposite. The direction of the flow is counterclockwise in both ways, because the area you just drew, that coil, if you're looking at it from this end, is facing you going clockwise this way, but if you look at it from the right side to the left side, it's going counterclockwise. The blue is going in the opposite direction, it's going counterclockwise. So they both are going counterclockwise in opposite directions.
Well, yes, but you gotta designate, are you talking about the physicality coil, or are you talking about the plasma flow?
Well, both. I think that what's happening with the flow is that it's it's going along the wire. As soon as it goes into the coil, the flows always coil exactly like this. So what it's doing is the flow of the plasma is actually going around and 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 coming out the other end. So it's going around the grooves of the inside of the coil. That's the direction it wants to go. In perpendicular to the flow it's going, but it's a coil, so it goes in one direction. So the plasma always tends to go in a counterclockwise motion, going away from you counterclockwise. So the blue gravitational would be getting pulled in. It goes into the coil and goes round and round and round counterclockwise, comes out the other end. The magnetical is going from the right, going in, going round and round and round and round and round counterclockwise and coming out. So they're both going counterclockwise, but the magnetical is going from the right to the left, and the gravitational is going from the left to the right. And so from those angles, they're both going counterclockwise. But when you look at them both from the left side, they're facing you. They're facing, looking at you, the face of a clock, clockwise.
Well, the thing about it is, though, that I would bring up is that normally, if this was in a maggrav system, you would have an applied negative and positive. Negative for the center and positive for the outer. That would be the way it's hooked up, basically. So you're inducing the gravitational and magnetical. But with this setup, I'm not convinced that the magnetical would be, the outer coil would necessarily have the flow going the way we show it here. Wouldn't it tend, since they're both wound in the same direction, why wouldn't the flow, for example, why wouldn't the flow in the red one go this way instead?
May I ask a question?
Well, even if it is, it's still going counterclockwise when you're looking at it from that direction. As it goes in, it's going around counterclockwise.
Mm-hmm.
So it doesn't matter. Either way, the direction of the flow is always counterclockwise.
Wouldn't the flow be directed by nano-coding 101 by giving ourselves the positive and negative direction? Because every time you make a coil, we're supposed to direct the positive and negative flow through the nano-coding.
That's what I was thinking, yes.
So
but we induce it, we direct it.
I thought that was basic 101 where you...
Hello? Something cut out there. Can't hear you, Mark. Anybody else?
Sorry?
Oh,
Sorry,
sorry.
I missed a little bit of that, but what Mark brought up about what used to be called aligning the coils is not so much setting the polarity of the coil, it's more making the pathway itself.
Yes.
Because when you do a basic nano coating, you've got a very random pattern in there. When you push your energy through that, you're actually adjusting that pattern to create pathways that the plasma will flow through. That's
right. That's my
more the reason why we do that rather than making the actual polarity on the system.
So
it wouldn't it be called direction of flow through our nano coating?
No.
In a very coarse sense, yes, because you're actually setting a vector for the plasma to travel through, whether it goes from left to right or right to left.
We're just asking the matter state to start from, because if you look at any coil that you can make a coil a positive and negative. If you turn it around from end to end, you look at it, it's a clockwise and a counterclockwise. If you just turn one coil, you can look at it, one goes in, one goes out. So I always thought that the directional flow, whatever which way you make your coil, is the nano coating tells you if you start from one end and complete the coating at the other, a positive and negative coating, then now the nano coating has something to do. did something
No,
on the
no.
material.
Yeah, and what if you direct it with fire? That was the indication with fire as well. If the fire was started at one end of this coil and went to the other end, or at one end and
Yep.
went to the other end, that
Didn't
would
they have
change.
trouble with fire because it flaked off, or even when you took the torch to it? Because I do all mine with caustic now, but even when you did it with fire, we were still told to try to put your meter from one end to the other, right?
Well, but again, all you're
Why
really
is that
doing,
to discharge them?
Yeah, that's
just
right. The
make
meter
sure
is
that-
mostly to discharge. That was a good point there.
Discharge, but when you discharge something, you give a directional flow, don't you?
It's more to take out the charge that's between the layers that prevent the layers from neatly layering, and the charge can puff up the layers and make it so it doesn't flow the plasma properly. Is the way I understand it.
Yeah, that process, Mark, you're not creating a negative and positive polarity within your nano coating. You're just creating tunnels through it.
So that you can now place a positive or a negative flow of plasma flow through a matter state. Now you've just told me that it just makes a hollow tube through a matter. Okay, we have the copper is matter, the nano is semi-matter, and now we've made a hollow tube that we can directionally put a flow, whether it's positive or negative, right?
Mm-hmm.
So
Yeah,
because all our GANTS material that moves through these through our nanoparticles that are bonded to a matter, copper, we have to have some way that's bonded to it, right? We're using the copper to bond the nano and transferring the semi-matter, which is nano, to GANS, which is now almost a plasma state. Now, once you move from these three steps into a plasma field, this is what the ultimate goal is. We're trying to get a field from these three steps, right?
Well, it's leading us to working directly with the plasma fields itself. It's like with the health pens, what we're looking at on the screen. Once you learn how to use one of those and you get good at it, you realize you don't need it anymore. You can just use your finger.
Well, John, come on, please. We're small in a small. We're learning this stuff as fast as we can. But yes, in a small. Can somebody help me out here, Denny? Anybody? Like, did I make sense there, or am I out of my mind? Where we're trying to go through these steps to get.
Now, look, when you're making nanomaterial, the copper wire itself conducts a plasma flow. Electricity is really the magnetic field spiraling around the wire.
Yeah, so, I know, Mario, that we don't,
but it's not superconductive because those fields, because the copper is bound together really tightly. So when you
matter state, it's a
you're creating a superconductive environment for the plasma to flow. That's all you're really doing there.
I know.
With the GANSes, you're getting a free nanomaterials. So they're nano layers and they separate themselves in monoatomic structure. So there's no copper, there's only the individual atoms. But all of that stuff generates fields. Everything generates a field. But this is just a way to conduct the flow. Like John was saying, I mean, I was joking last time my pain pens would give pain. But, I tried it on myself. And it was really badly made. I mean, it was really badly made, but I tried it on myself and it worked.
Mm-hmm.
Like John was saying, all of this stuff is just to teach us that the plasma exists. It's there. It's always been there. You are a plasma generator with the field strength of your soul in your brain. So of a human, of a man, so we were all getting iodine and I got the fly's soul and all that stuff. Well, but I already got it. I already got it in a reactor. Why am I not using it? Well, for one, I didn't know I had it. I didn't know I had fields. I mean, I didn't know I was a god, so to speak, So having a knowledge of that is what all of this is about. But anyway, I didn't mean to diverge into another thing, but everything.
Can I add something?
Yes,
Hello?
go ahead.
Before we get too far away from the nano coding, it seems to me that we should kind of define our terms a little bit in that we are making nanotubes. That's the word, nanotube. Let's get away from this nano coding and just realize we're making a nanotube.
Wait a minute. Where are you making a nanotube? Where are you making a nanotube?
Okay, anytime
we're not talking about carbon nanotubes. Is that what you mean? Carbon nanotubes or copper nanotubes?
Yes, copper nanotubes. Every time we coat one of our copper wires, we're actually making a nanotube. If you remember, Mr. Keshe recently said that soon he will teach us how to take the copper away and just leave the nanotube. And I think the copper is just a support system that we use currently. Pretty soon it'll change, I'm sure, because Mr. Keshe said so. So I think a lot of confusion is brought about with constantly saying nano-coated.
No, I totally disagree with what you're saying there, Don. I totally disagree. I think we're not creating nanotubes necessarily. It might be possible to create copper nanotubes, but generally we have a mishmash layer of copper. It would look more like a bunch of graphite or something, like layers, or it could look like scale, it could look like little pyramids, it can look like little spheres. All these different shapes are available for copper as an oxide, and to say that they're copper nanotubes only, I think is totally, it goes against what I've seen in the pictures, the microscopic, electron microscopy, or the other tests they use for the copper surfaces. There's many different surfaces.
I stand corrected.
Like if it's like nanotubes is a common term used with carbon. The carbon nanotubes are highly studied, the most studied thing in physics now, actually. And it has diverse, extreme possibilities for all kinds of wonderful things. But it's not something that we generally are using as far as that carbon nanotube technology. And it is possible to make copper nanotubes on the surface of the copper, but it's a specific process. It's not that easy to do just with dumping the caustic and expecting it to grow that way. But when Mr. Keshe was talking about that process, he was talking about essentially taking a wire, an ordinary copper wire, and then nano-coating that, and then essentially melting out the inside part of that very thin little wire and having just the nano-coating left after you melt out the copper. And it could be melted out by, acid or other types of baths that could dissolve the copper. But essentially that was the nano wire or nano tube that he was talking about, creating not little nanotube like forests growing on the copper, but like a long thin tube that could transfer electricity at very high voltages and very efficiently, for example, and so on.
Yeah,
Okay,
Don,
I stand corrected.
yeah, Don, the electron micrographs that I've seen of caustic nano coating, it looks like a city. You've got millions of different shapes of structures all set up in like streets and blocks, and it looks like a city. And it's what we're after ultimately, is the space between those little bits. That's where the plasma wants to be, because that's where your superconductive properties are, is the space between those little structures that we're creating.
The exactitude of that space.
Has anybody taken any pictures of plasma coated copper? Be interesting to see the difference.
Well, I wouldn't know how to take a picture of plasma. You're talking
No,
about.
I mean
I
the
was talking about the
nano-coated.
nano coating. Well, we should
Yeah, I
have,
mean the
we
nano-coated from
should
a
have
plasma
a,
stream.
we should have some, lab set up or some place that we can send all of our samples, a central place to get regular tests done that, it's standardized kind of pictures so we can see what we're creating. I think that would be great because each process, when there's slight variations in the process, will give you a slight variation in the coding, and some will be more efficient than others at certain jobs. Basically, that's the whole thing about this nanotechnology, and is why it's becoming $1 trillion a year business now because of all the different offshoots and so on. And it's all in the fine details of how the processes are done. Some of them are done in a vacuum and some of them are done in room temperature and pressure and so on. And most of the time we are just putting caustic into a bucket and hoping for the best because that's the way we've done it. And generally it works. And if it works, then why change it in a way? But on the other hand, to fine tune and to really become professional at it and to take it to the next level will require knowing more, using all of the facilities that we have and resources available to know what we're creating and know why it makes a difference and so on. A lot of it is the geometry. When you create a pyramid out of copper oxide, then that's a way different structure than a thread or a tube or a rod that's created. And especially when you get into zinc oxide, for example, the zinc oxide nano rods, which can be created, happen to be piezoelectric. When they're bent, they give off electricity and so on, whereas the copper ones don't tend to do that. So there's a lot of variations, a lot of technique that we can learn. And I think part of that is we need some good pictures of the microscopic level of get right down to the geometry of what we're creating. Is it a nano city or is it a city of pyramids, for example, as opposed to cubes?
Well, let's put it out there, Rick. Let's put it out there. If there's anybody out listening that hears this, that knows anybody or has access to a sub-picometer electron microscope, let us know. We can certainly use your help.
Yeah, maybe in a university somewhere, and they could become like a central place that we could send the samples to try to get more of a handle on what we're creating and why some of them work and why some of them don't. For example, it'd be great to have some really detailed pictures of some of the fire-coated coils. And I understand some of them aren't working as well as the regular caustic nano-coated ones. And
Yeah, the couple of pictures that I saw, the fire coat was extremely fine. The resolution, that were all 5 micrometer resolution pictures, and the fire coating it looked like a beach, like you're standing there looking at the sand of the beach. That's the kind of a surface it had. Whereas the caustic coating was very coarse. It looked like you were 100 feet above a city.
and more levels
Massive
to it,
scale.
more layers probably, yeah? More.
Well, I don't know about more layers, but the caustic coating was dramatically more coarse than the fire coating.
And lots of different kind of heights and stuff like that, like
Different
high
heights,
building,
different
low
volume
building.
structures. The cracks that showed between the structures were all different sizes, where the fire coating was a very smooth, very uniform type coating.
Mm-hmm.
There was one other thing,
Go ahead.
something about the copper tubes, the nano copper tubes. Mr. Keshe said that the way Renan and those guys had the water leave the center of the ball, he said you use the same technique to remove the copper from inside the nano coated.
Oh, that's interesting. Thank you for that. That's somehow makes sense.
Yeah, make a reactor that sucks up copper and put it next to your system, and it'll just suck all the
Basically.
Yeah,
Basically.
and it'll leave the copper oxide alone.
Right, right. So that's, I don't
I
know how
mean,
to
if you
do
think
that
about it,
exactly.
if you think about it, there's certain acids, for example, that dissolve copper. I mean, vinegar will actually dissolve the copper. So you could theoretically create a little reactor with your copper wires that are nano-coated, and I think that if there would be a way of doing it that it would take away the copper without taking away the copper oxide. That would be the
Yeah,
trick.
just
Probably work, but you got to worry about the structure of the nano copper without the substrate collapses on you and just end up with a pile of dust, so to speak.
yeah.
Exactly.
Don't sneeze when
Get it
you're.
out of the
Yes, it
vinegar.
sounds like a delicate situation, all right.
Yeah, that's the biggest problem. Yeah, but if you could just remove it, so you leave it intact, and I mean, it would be pretty fragile. But if you could just pull out the copper with a magnetic field or gravitational field, whatever, and then leave everything intact.
Well,
That'd
in
be,
theory, over time, you would expect all of the copper to wind up converting
yeah.
to a material.
Well, that's right, especially if the wires started out very tiny to begin with, like our fine wire, speaker wire, and so on, that nano coats so readily.
But then, do you have a tube? You don't have a tube then.
Well,
You need that hollow center.
Well, you'd have a snowbank that you shot full of holes, essentially.
Yeah, I guess so. Yeah, maybe. Yeah.
maybe the tubes would be the space in between the wires. That was the only part left that was not nano coated. Interesting.
Yeah.
Okay, I've got Mark. You've got your video on there, so I wanted to show your lab arrangement. It's looking pretty neat and tidy looking there, with all your GANs bottles lined up and so on. Is there something you wanted to show us? And also, Don, I was wondering, you got your video on. I'm wondering if you wanted to show us something of your system there too, your situation.
Whoever wants to go first, that's fine. I just want to put something up there so that we don't. My face isn't that pretty, so at least my lab is neat.
Same is true with me.
That's why I'm not showing my picture or my lab.
You know what they say about a neat desk, right, Mark?
Well, no, I don't, because I've never done this before.
Okay.
Well, that's why we're amateur scientists, don't you know?
Pardon me?
I said the reason we're so organized is because we're amateur scientists.
So Don, this is Denny. Are you the fellow that started out using some carbon rods to make GANs?
Yeah.
Did you hear me, Don?
Yes, that was yours truly.
So are you still doing that? And what kind of differences between your GANs have you found?
Well, I can't say that I've found a lot of differences other than the only thing that I've changed recently is I went from a sea salt, which would be a rock salt, so to speak, is how I buy it. And then I moved to iodide salt, and it does seem to change the color of the outcome. But other than that,
yeah, that's really to be expected. You're completely changing the conditions that you're collecting. And it's just NaCl, basic, and that way, every time I do it, it's a little more consistent than if I'm changing the salts. Because I've done it with gray sea salt, pink sea salt, iodized regular table salt. Each one produced slightly different conditions.
but the end result still seems to be the same. It is again, particular metal you're using. Do you agree?
To some extent, in a lot of cases, the way we're working with the GANs right now, if it's a little contaminated, it really doesn't matter. If you've got 60% CO2 and 40% zinc oxide, it doesn't matter. It's still going to function. We're not to the point yet where we need the absolute pure GANs. It's coming. We're eventually going to get there, where we're going to need specific ratios. But right now, with the experiments we're doing, the ratios really don't matter that much.
I see.
What about
The only thing else?
what about the straight NaCl sodium chloride crystals? Is that the best way to go in a way? It's the most pure. You don't have all the other elements and minerals involved. It's well, that's caustic soda. That's not salt though, right?
Yeah.
Well, what would that be? What would that be called with a scientific label?
Sodium
Is this
hydroxide. Sodium hydroxide, NaOH.
Okay, that's,
Is that
I'm
straight?
trying to improve my grade.
Is that straight NaOH? That stuff they showed there, Don?
Yes.
Right.
Yeah, and the materials that I get from Home Hardware as well is it's pure lye. It's 100% pure NaOH.
Yeah, I get the pure stuff as well. I was talking about NaCl, like sodium chloride, the basic salt.
Yeah.
Is there a better
plain
result?
salt.
Is there a better result with using plain sodium chloride as opposed to sea salt? That's my basic
I don't know about a
question.
better result. I'm just eliminating variables. That's all I'm working with right now.
Because sea salt always has the variables in it. It's always got, I might have a potassium chloride and some magnesium and all these different elements and so on, everything in the world basically in it. So why wouldn't we just start with NaCl? So it's just the sodium, the chlorine, the copper, the oxygen, and the zinc basically are all the things that are interacting, and we don't have all those other cross interactions and different things. Like, what color GANs did you get when you had the straight NaCl, Don? What's the variation in color that you mentioned that you see there?
I
For
don't know if I can
example,
answer that.
like well, anybody can, I guess. For example, the CO2 GANs, what we call CO2 GANs, usually white fluffy stuff. Is there any difference when using the straight NaCl as opposed to sea salt? And the same goes for the color of the copper oxide, the blue green or bluish copper oxide. Does it change color, or is there any quality difference when using straight NaCl compared to the sea salt? I'm wondering.
Well, with my experiments, when I did my first few batches of CO2, like I said, I used gray sea salt, pink sea salt, regular iodized table salt. I didn't use the pickling salt at that time, and my GANs always came out kind of a very light, kind of a not a I have to say beige, but it's not that brown. It's very, very subtle. It's kind of it's a little bit of an off white. When I did my CO2, the last batch of CO2 using the pickling salt, it came out a very, very slight blue. Now I'm comparing these to lead GANs, which is almost pure white. And when you look at it side by side, I can show you here. This is my lead GANs, and this is the last batch of CO2. It's a very, very slight blue.
Wait, I can't see that.
This is my first batch.
We see Don. That's what
here,
we're seeing.
let me spotlight. There we go.
Okay, there we go. There's lead GANs, which is absolutely white. Compared to paper, it's white. Okay, this is the pickling salt CO2. You notice it's got a very slight blue tinge to it. And this is the first batch. This came from the pink sea salt, and this has got a very slight sort of a gray tinge to it.
Mm-hmm.
But this batch here, This is probably, I would estimate, around 30% zinc, just by looking at the consistency of it. And this is very close to just CO2 because it's like super light, super fluffy. It's physically dramatically different than the other batch of CO2 that I made.
Any conclusions as to why you're getting the different colors? I mean, besides the salt, obviously, but I mean, what's going on there?
Different conditions. The plasma strength is just a little tiny, slightly bit different because of the different conditions it was made in.
So the color is giving you the frequency, basically, of its fields, I guess. And there's a difference.
Mr. Keshe mentioned that, you can have CO2 GANs, you can have it a slight pink, you can have a slight blue, it can be a slight yellow, all depends on the conditions it's made in.
Any idea which direction the color is telling you, stronger or weaker?
I don't think it's a matter
blue or
of
stronger, you think?
I don't think it's a matter of stronger or weaker. Is an A string stronger than a B string?
Well, the higher pitch, yeah. It's got a higher frequency, so it's
not stronger, it's different.
Well, it's going up in pitch takes more energy. A singer, a trumpet player, anybody, the higher strings have higher tension on them. So yeah, it does. It's a higher tension.
But when you're reproducing sound, the lower frequencies take more energy.
No, they're lower. They're lower. No,
is going to produce the same SPL as a 10-watt tweeter.
No, I don't think so. No, the higher pitch is more energy.
I've done audio engineering for years, buddy. Look at your systems. Anytime you have a tri-amp system, your tweeter amplifiers are tiny, your subwoofer amplifiers are massive.
Because the higher energy puts out the same volume at a lower mass.
Lower.
In other words, you're looking at it the inverse way.
So if you put that 1,000 watts, if you put that 1,000 watts instead of the bass, you put it into your high-end tweeter and had 1,000 watts, that would probably blow your eardrums out compared to the 1,000 watts of bass.
Yep.
Right. So that's showing that the higher pitch has much more energy. It'll blow your eardrums out.
But we're not looking at the end result energy. We're looking at the energy required to create it. That's what we're discussing here, is the conditions where the GANs is created. So it's going to be, if you have a different energy level in your creation process, you're going to wind up with a slightly different GANs.
Well, I'm thinking like from the outside in, you have A, B, C, D, E, F, G, A, and you have the 7 colors of the rainbow. The lowest frequency would be the infrared on the outer layers, and the higher frequencies is the ultraviolet, the blue. So you're going, and Mr. Keshe does the spiral, the closer you get to the center, you're going from red to blue, and you're going up in pitch. So those are high, those represent, I'm sure the musical tones are frequencies of field strengths. I've come around with what Armin said and what you brought up months ago. And Armin came in and said, it's not frequency, it's field strength. But I'm convinced now it is frequency, because it's got its own field strength, but then everything's interacting with everything else and they're vibrating. In fact, I just discovered something about a spiral. If you take 2 spirals and you put them back to back and have one going in one direction, the other going in the other direction, you get a series of circles, which is a very interesting thing. I'm not ready to show. I've got bits and pieces all over the place. The field strengths go up in pitch. The higher string, if you want to have a higher pitch, you have to increase the tension. So
there's a mixture in there, Mario. CO2, looking at a CO2 GANs particle, for lack of a better term, field Coulomb barrier, whatever you want to call it, is going to have a certain field strength. Now that could be vibrating at 100 angstroms, 102 angstroms. Okay, it's not going to change the field strength, only the frequency that it's emitting that we are perceiving with our receivers, our eyes, and that's where the color comes in. That's where the color change comes in. It's really nothing to do with field strength. It has to do with the vibratory rate that we're perceiving of that Coulomb barrier.
Wait, but there's 2 things about field strength. you can increase, like when you talk about strength, if you double the mass, you have twice as much energy there, but it's still the same pitch or field strength or color. I think that's why CuO is a higher field strength than CO2, and it's blue. And CH3 is weaker and it's red. See? So those, in a way, those I'm trying to fix musical tones to those. You know, find where is the hydrogen? It's on the outer layer. It's infrared. It's the red color. And as you go up, you go past the white is deceptive because it's grayish and I'm not sure how that works. And that's also a composite. I don't know, but I haven't. But you see what I mean?
We can have CO2 and test it, and yes, it's CO2, but we can have CO2 that's got a blue tinge, and we can have CO2 that's got a red tinge, but it's still
right. But you have CuO is always the blue.
But it varies within that blue spectrum.
Of course, because everything's a spectrum. They're not all exactly the same pitch, but you've got them. But you've got variations in what can be in tune and what can't relative to each other. So you've got CuO, but if it goes past a certain color, it's no longer CuO. Like mine is going black. It's probably it should be CuO2. It's probably become CuO, or it might even be a GANS of I don't know what it is, or just material or whatever. But the color tells you its field strength, independent of its mass, but its field strength dependent on its frequency, how it interacts with other entities. So in the Earth, the copper oxide is blue. It's stronger than the CO2, which is a grayish, whitish, maybe a bluish. And then that's stronger than the CH3, which is red. So you can place them in the spiral. The CH3 is on the outer coils. The CO2 is in somewhere in the middle or a little bit closer to the and the right like that. And
yeah, I think you're confusing field strength with energy density. Very different things.
Well, the energy density is what I'm talking about when I'm calling it field strength, calling it like in generally speaking, field strength as copper oxide is stronger field than CO2. But you're right, there's a density of the fields because they're closer packed and they're closer into the spiral. There's more mass. In the flower of life, the closer it gets to the center, there's more lines crossing, there's higher mass. Plutonium has higher mass than hydrogen.
Yeah, it's not quite what I'm thinking of as far as energy density goes. That's more of a matter state consideration where you're thinking density is you just pack it tighter and tighter and it gets more dense. Yes, that's accurate. But in plasma state,
no. I mean the fields. I'll show you a drawing here. Let's show you a drawing. It's the fields are more dense in the center. If I can find this drawing, show my camera here. Can you see this drawing?
Okay, I don't think I can. Oh, there we go. Yep.
Okay, my screen just froze. Okay, there you go. Okay, now you see hydrogen is going to be out here. See, it's going to be in these layers and it doesn't have as many fields interacting, where plutonium and uranium are in here. See, there's just many more fields. It's not a matter level understanding, it's a field strength. This layers, I've got these spirals I've done. I'll show you the spirals. See, I'm putting in the flower into the spirals. See, here's a version of the proper periodic table of elements, where those dots are, where the elements go. And you can clearly see there's more mass. It's hard to see here with the pencils, but at the center here is extremely dense. And then it's less dense and less dense and less dense and less dense. Here's blue, here's infrared or ultraviolet infrared. And as you go in, the colors go shifting from red to blue. Mm-hmm. So CH3 is red. It's one of these layers here. CO2 is one of these layers here, and or probably back here, and the CuO is in here, it's more blue, and you'll keep going up, and uranium GANS is going to be higher, and it's going to be more blue. Be interesting to see the GaNs of that. But you see what I mean? That's a field strength understanding of it as mass. That's really what mass looks like. That's why if you have gold GaNs, it's here, say, for example, and it would be A, B, C, D, E. Okay, there's your gold GaNs relative to the tonic A. If you have a gold GaNs, then you have all the fields from the center out. So you have uranium fields, you have plutonium fields, and you have everything above the field, what we call the atomic mass, going in. But you don't have, you know, iron, and you don't have helium, and you don't have hydrogen. But if you have a hydrogen, then you have these fields. So the fields have to start in the center and spiral their way out till you have hydrogen. So if you have hydrogen, you have the full spectrum. That's why having atomic hydrogen, you have everything.
In a small sample size, yes, I totally agree with what you're talking about. But I've got a piece right here that is lead GaNs.
Let me see. I can't see your screen.
Yeah, there we go. That's lead GaNs, and it's white. It is like as white gets. It shouldn't be. According to your theory,
because the human eye only sees one octave. We hear 7 octaves, but our eye only sees 1 octave. So these are going up in octaves. For every layer, it's going up probably 12 octaves or 9 octaves maybe. So you're up. I mean, what we're seeing is white. It's because our eyes are not actually seeing those frequencies. Be interesting to look at those in infrared and ultraviolet cameras and those kind of lights.
Well, right now, Mario, the sample size is too small to make any sort of definitive conclusion on this.
I agree.
We're seeing that this doesn't hold to reality. The gold GaNs, I've seen some gold GaNs that's purple. I've seen some gold GaNs that's gold colored, yellow.
Lead we haven't done spectroscopy. You don't know what else is in there. And so you're getting composites, so you're mixing colors. You know, that, I mean, what happens when you mix some blue and some little bit of other color, you get a third color that really affects that. You get a brown, but you really got two, you know, a brown and a green and a whatever. So all it takes is a drop of one in a lot of the other, and it changes the color of all of it.
Yep. Mario, how would you think that you would make pure gold GaNs?
Well, there's lots of ways of making pure gold GaNs, but you're never going to get, well, we might be able to get pure GaNs, but only in a direct fields. Only with direct contact with the fields. If you're using any kind of gold,
Mario, we have to start somewhere. So how would we start?
Well, what you do is you learn how to make, you learn how to make a proper periodic table of elements that tells you the exact placement of fields interacting with 2 reactors. And so then you adjust the distance.
Are made with copper. Wait a minute. Wait. We got to go with the pure gold GaNs field.
No, if you're going to make any pure fields, you have to do it directly with the fields. Otherwise, you're going to always get composites because you're never going to get anything pure. You cannot, even your gold is not pure gold. You're getting
99.9% gold is about as best we're going to get. We're earthbound.
That's right.
We're earthbound.
No, but there's a way to get 100% gold.
How?
Because you take 2 reactors that are generating.
We don't wait now. Wait. No. We don't have reactors. We have to start from point A.
You take 2 reactors and you put them together.
We don't have reactors. We have to start from point A. You know what I'm saying?
Starting from point A. You take 2 balls that have balls inside them, and you put them together so that they push together so that they're pressing against each other at the right layer. And you'll get whatever field is at that layer. So but you got to know where those layers are. That's what I'm trying to work out with this, but it's going to take a lot more than me. But that's the idea, is knowing where gold is within the spectrum of the field you're creating. Gold is just is note A. So if you tune 2 reactors to get A, you'll get A.
Mario, we're in a hypothetical situation here. I went out and bought gold, cut it in half, 99%, put it in caustic, did the whole process and made what we made.
Okay,
I got what we made.
Still have some NaOH in there, which means you got some nitrogen, you got some oxygen.
That's what I'm saying. So what would be the next step in how to make gold GANs in order to go to the next step?
You don't have to make gold GANs to go to the next step. You can use the 3 basic GANs if you know how to adjust their differences. If you understand where the layers are. If you have a CH3 GANs, you're radiating a field. Right now, if it's in a reactor and it's creating a dynamic field, it's creating a layer that spirals out past gold. So there's a layer of the gold, the fields of gold in your CH3. So where is it? And how do you interact with it? You use another reactor that's in the reverse, and you push one against the other. Mr. Keshe has done this over and over and over again on the board. There's nitrogen, and he runs more lines, and those are lines are the layers of the fields. And there's gold. There's pure gold, 100% pure gold. But there's no other way to get it 100% pure gold unless you can create it from the fields. But that's how you do it. No, I mean, am I wrong on that? I mean, I thought that's the whole, placing a gold GANs near 2 reactors that are interacting, that is finding that's a way, it's already gold, so you've already got that field, so it's finding its mate and it's raining down in there. So that's why you're going to get gold in between your 2 reactors. There's a way to not need the gold GANs if you could find that field without it. And I suppose if you do it enough, it'll probably remember. And so, all you need to do once you've done that enough times, you probably go, I want gold, and you'll just get gold there because it's already been stored, so to speak. But I don't know. Am I not thinking right? John, you stop talking.
I think I think you're definitely onto something. Whether or not it's going to work out to be anything that is going to really make a difference at this point, it probably doesn't, because again, most of the stuff we're working with, we've got such a broad bandwidth that we can work with that a little contamination is going to matter. Nobody cares. Now, when we get to the point where we've got the little, microwave sized box on the counter, we walk up, push a button, and say tomato. Yeah, we're going to need to be a little more precise, but we're a long ways from that yet. Now, Mark, I'm looking at your system. One thing I can tell you right now is you're going to have a really hard time hooking that up.
Hooking it up to what, John?
Well, if you're building the wireless dynamic reactors, your connections between your outer maggrav coils is way too big.
Outer dynamic, out, in. Wait. My outer.
Okay, that looks like it's a complete departure from the current version of the dynamic reactor. So,
yeah, it is.
Okay.
Okay, Mark, explain what you got there.
Hi, Denny.
Hi, Mark. And I'm also interested in Don to see what he's up to now and where he's going to. So, Mark, explain what you got here so that all of us can enjoy it.
Be creative. Well, it's a version, right? We're supposed to think out of the box, right? So in the same version of, the V2 or whatever, I just kept thinking about it. And in the V2 version, let's see. Let me put a light on. Let's see if that helps.
It's just because you got black on black, it makes it difficult.
Yeah. Maybe I should, well, here, let me do this then. Let's do this.
That's a little easier. Gotta love plant foam, eh?
Right. Cause I overthink some things and then I think of some things, and that's why I didn't come on last week, because I had to take a break about how I had to think about things. So is that, can you see that a little bit better, John?
Yep.
Let's see. Let me play with this for a half a second to see if we can get a better.
The light's really not making a difference. Just turn it off. It's about the best you're gonna get.
Okay. So anyway, so these are real small. They're handheld units. You can hold it in your hand. So, you know, in the V2s or whatever, we're just trying stuff, right? And so, like we said, you know, you said the wiring is right, or I don't know if there's wiring is right or wrong or whatever. So what I did anyway, inside the 18 turn coils, these are all 18 turns. I have outside to inside, and then it wraps around, and then it comes out to the outside, and it's just an arm connection, and it goes to the inside, which is your gravitational, which shoots it back out, which is connected back here. And I'll explain why I connected the way I did back in the back here. There's a certain reason why I did what I did back here, because I put a lot of thought into why, you know, our spirals go down into the middle. The reason why we go down into the middle is because this middle coil in the V2 is, you know, we've treat it with lead, or we want lead, and I can get into very specifics, but these are just in a prototype, but I've designated the center as lead as my my drawing point. You know, we want to draw the field into the middle of our feet, you know, into our magnetical and gravitational field. And in the back of it, because it's a single coil, one coil in the middle. It started, I made one. This is an 18 turn with, you know, so much on the end here and so much at the end here. So what I did was, because I know this is my center point, just like a battery or a carbon, everything goes to the middle. So what we want to do is bring things to the middle so that each unit has its own designated gravitational and magnetical field to do what it has to do, but it has to have a direction. So that's what I was asking about when we nanocoat stuff. So I decided that when I started this project that I would use this as a center point, and I always put the negative coil or the negative thing from my to directionally put direction negative, and then I started with the positive. So every time I did stuff, I put the negative here, and then on an outbound you have to touch it right here at the outbound where the magnetical, because you want the energy is now started from the middle to the outbound, and then it goes to the inside. And I'll show you why you want to go to the inside, outside to inside, outside to inside, outside to inside. That's what these things are down here for. It's very easy to think about, but probably technical. I'm a painter, you know what I'm saying? So anyway, that's what I did here. So now I told the nano coating wires, this is what I want to have happen, is to, because I put the direction of positive to negative from, this is always going to be the negative. So what I did was, so that I made sure that everything from the center coil here gets to the center coil of each one of these small mini Magrav coils, what I did was, in the middle here, I took a little nano-coated wire, and I put a little hitch, a small coiled hitch. I don't know if the camera could pick it up, but I put a little hitch. I drilled a hole through here, and I put a little hitch on the very bottom. It's not touching anything. It's just a coil, a nano-coated piece of wire coiled at the very bottom. And I'll tell you why I did that, because I just need that center pin. If I just had a straight pin, it would just kept coming out. So I just took this piece of nano-coated wire here, shot it through the plexiglass, and made a hitch. And now it's stuck, now I can pull through it, and it's tight.
Drop it down into view a little bit better. There you go.
Okay. So I made a little hitch in each center pin for each unit. So now what I did was, now that's a central, it's going to bring the negative or our pull in the middle of each one of these units to the central point, which is a complete coil from top to bottom. And I brought the whole wire out and made because I want to be able to hold it. I'm going to put a piece of, PVC here. I'm strong enough to hold it. Mr. Keshe told it, when you hold it like this, don't be scared. So, but I'm still working on it, and there's still stuff coming out. But anyway, so this is my center negative with lead and mercury. I made a complete GaN solution for that, because we know that I've worked with all my GaNs, and I know now that you have a high pH and a low pH, and that's what he told us, to mix these pHs up so that you can get a reaction. And I have it all written down from that. So now we have a central point where all three of these units are going to go into each other, not touching each one of these. These units, each one of these come out with two wires, right? And I looped them because they touch the pin right here that comes to the central point. So they can decide, because, in the V2, at the end of each one of the units, they just came together and laid there by themselves. Like if you went back to that drawing, the V2 drawing, at the bottom of each coil, these coils come together and just laid by themselves. They just loop together. That made no sense to me. Well, because it's probably a field that just decides what it wants to do. Well, I'm deciding that it's all coming together right here because it's going to be a field that goes here. And maybe I'm taking up a lot of too much time here, but I made a couple of things here, Denny, that like these will be filled with the solutions that my GAN solutions with a nano-coated copper wire, so that I'm guaranteed it comes, I get something that comes out. And I made I hot wired it, and it's a dead end here, but I don't, we all have to have a dead end somewhere. But this is a hot end where it's going to show us that, and I've already, through the meter, I already know that the nano coating will bring out whatever GaN solution I put inside these. And these are my like GaNs balls that we put in the middle of things, like our mini magravs or our full-size magravs. These are just small vinyl tubes that I filled with hot glue between each end, and I got a end that's going to be able to work with it. And then I had to think, which side should I put it on? Should I put the open live end up here, because I have small ones that are be filled with well, when we treat our nano-coated wires with CH3, CuO, and CO2, I've already started treating this one, and I can show you that, but a lot of process. But this one with the lead, 3 different types of lead, mercury, and tin, which is going to go into the bigger ones that fit in the middle. And then I thought, well, should it be an open end here, or should it be a dead end on? And I'm still working that process out, because I have smaller ones that go in here that will be charged with CH3, CuO, and
I got to stop just for a moment, Mark. When you say go in here, are you putting it into the center of the coil? When you said go in here, you got smaller ones that go in here. Are you dropping it down into the center of the coil? Is that what you're saying?
Yes, I am, Denny, because these are my interchangeable. If we need to change these, I can make these little they can be, I can put a drop of CH3 and put a drop of gold and put a drop of silver, whatever combination. I can make 1,000 of these with, and then just cap it with just a drop of hot glue, and then they just fit right in there.
Yeah, they're little reactor rods, and you can even vary it by putting them in partially or in all the way, and maybe have
They're hot rods. So do you, and then I have to think about, because this end here I've designated as my negative end, because in the center is my lead and a couple other negative, low energy pHs that I've come up with. A soup of things that I've now been treating the middle with, that will end up in the middle, host that holds this. And each one of them have an opportunity to come to the middle and feed off of it, because each one of them I wrapped around, because it's a center pin that came out to the middle of here. They're all,
So, are you going to stack up these units, or all 4 of them? How are you going to? Are they 4? They're 4 separate units.
You can do whatever you want with them. They're handheld.
Oh, okay. Mm-hmm.
You know what I'm saying? Once I'm completed with them, I'm going to have, I could put CH3 with a little gold, CO2 with a little bit of silver, and the combinations are endless. So I'm hungry. Boom. I got,
Yeah, right.
You know what I'm saying?
Yeah.
Because and
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 then
this,
you end up with a gold piece in your palm if you get the combinations right. If you need to
well,
pay for something, you just
well,
put the
it's a
device in your palm
generator,
and
a
generates a
small,
gold piece.
well, it would be a small magrav generator in your hand.
Mm-hmm.
You know what I'm saying? That could help you and feed you. It's a small, and then you think, well, you won't, we'll get technical. And with the needle, you can figure out that because um, in these, in these, when you can see the power when it comes up, if you touch it, if you hold the negative here and touch it here, it's a hot read. If you hold it here and go in, it's a low read. Low, hot, low, hot. Because it's it's banging itself. Bum 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 bum, bang bum 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 bum. And like I said, these are just these are feeders that in the end, now, do I take the open nano end, because I got the little hook end here, you know what I'm saying, that I got a little eye hook way buried in the end on the bottom of the plate here. Do I allow that nano end there and this nano end to touch each other?
Uh, that'll be the experiment for next week, so you can tell us what the effect is.
Well, I mean, and I got a little bit more work to do because I want to, and now because not I can tell you, because the bigger ends here that fit in here, I've been coating this middle with what I want to go in here. And the way you coat it is, I thought, well, how am I going to coat it? And what do I do? So because I have to, I got 100 experiments going anyway. So, but I designated some certain solutions for those materials to go in there, right? So I wanted, because I have 4 and I needed, tops and bottoms. And I figured out which ones for which numbers, like I have, 8 millimeters of lead in this one, and 6 millimeters of mercury, 4 millimeters of
Uh,
tin, in a combination of
milliliters, I think you mean.
milliliters. Yes,
Yeah.
I'm
Okay.
sorry. Yes, milliliters.
Mm-hmm. Yeah.
And that's how I started my process of the middle, because we know lead is an attraction, and these other materials like mercury and tin are just in the same family. And then I just reversed the process in the bottoms, like I put, but I changed it just a hair because these are positive 864. I changed up the bottom to 753 because Mr. Keshe told us that we want to constantly, for gradients, you want to constantly change the gradients. So that's what I did for the center core. And I made these small solutions in these containers, so that I could just treat them with a Q-tip. So what I did was I just keep dipping, I have 2 of them in one solution. So I dip and just kind of wipe it around the side. And in that thing that I had, it would just drip down. So now I know that this one, would get that, and you just dab, dab, dab in the center. And that's what I'll continue to do with CH3, CuO, and so on and so forth. And then I'll be able to put those materials, and I'll mark on the tubes here, you know, uh, core 4, CH3, core, and I'll be able to put that in there because they're easy to keep track of. That's what the whole thing is, to find out how much we got to keep track of each one. And then when it comes to GANs, everybody keeps saying, oh, well, do you what do you do with the GANs and why are you making the GANs? Well, sir, I'm telling you, I've been tracking GANs for quite some time now, and I have just. I know I'm taking way too much time, but I got way too many questions. But I got one in specific questions because a lot of people are making ganses. Is any, because sugar and salt, or molds will start to create, with your maple syrup, Rick. I'm sure if you started to do it even at a slow process with, with caustic, after a while, you'll start to get bubbles, and then the sugar will ferment, and now you start to have molds and
Yeah, I'm not sure if that'll happen with the caustic. It probably depends on the concentration, but for sure, if you were to leave maple sap or maple syrup out for very long in the air, especially, it will definitely oxidize and go moldy and so on. Yes, absolutely.
Yes, so I have some ganses that have really high pH levels. I take readings. I've been taking my pH readings for a long time, but the most ones that I'm so concerned about is, well, gold and silver, and I'm sure people made gold and silver GANs, but the gold GANs, I mean, once you take the pH reading on it could start out as high as maybe pH of 8.1, 8.2. And if you leave your pH meter in it, it will drive down to pH of 6. If you wait over an hour, the thing will start from 8 to go to 6, meaning that it's transferring energy in the gold. And I'm sure gold has the ability to do that. And I'm not questioning that. The second,
Excuse me, Mark, I'm going to backtrack for a minute. Just for the fun of it, would you tell us how you did make your gold GANs?
I made a video of it, and they didn't they won't post it, but it was pretty simple, Denny, and I still have the pieces for it. All I did was take a 99% piece of gold. I went to the gold exchange place. Where is it? And I cut it in half, and then I just soaked the half of it in caustic solution. Where? Oh.
And then the other one was you soaked one in the caustic solution, so you nano coated it.
Yes.
And then you left the other half that you cut unnano coated.
Yes.
Yeah. See, I understood what you were doing. I'm just was wanting you to articulate it, so if anybody else.
And I made sure that when I put it in the caustic solution, because you got to put a little bit. You could probably let it for with a nano coated wire for months, and so all I did was just put a less than a battery's worth of power through it. With positive to the non-nano coated piece of gold, and the negative to the nano piece of the gold. And then we talked about it a couple of months ago, a month or two ago, because we figured out that there might be some starch in all these plastic containers. And I still had the container that when I made it in, it stained the bottom of the gold stained on the bottom, because remember I said, we all said, well, it made gold GANs. Here's the gold GANs. I have it right here. There was black and blue stuff on one side and just real clear stuff on the other. And then I washed it in CO2. Well, I washed it. Well, I first, you cleanse it in the distilled right off the bat, just to boom, right off the bat. Then you CO2, and then a distilled, and then you're ready to go. And all that black and blue stuff washed away. And I still have gold GANs you know, still looks the same. Get up.
It's a bright orangey. Yeah, we see it there now.
Thank you very much for explaining that, Mark. Dawn, are you still there? If you were to do this using a carbon rod, how would you do it?
Well, I can show you what my results were using iodine salt, using 1.5 volts and 0.05 amps. This is what I ended up with. I don't know if you can see it or not, probably not. It's kind of there's very little in the bottom. It's kind of a blue color. I think you can see it now. That was my second attempt. My first attempt with using the copper rod was what I culture. I put the lead or alligator clip onto the gold and let it go and didn't pay attention. And my lead started to dissolve, which is steel. So now I have a combination of gold and steel GaNs, and that turned the color of a kind of a brown or a more iron color GaNs than gold color, which is kind of strange. You shake it up a little bit and it has chunks, as you can see. I'm not sure what that's about, but it's interesting nevertheless.
Did you, in that experiment, did you have the alligator clip in the solution?
Yes, that's why I think.
Was it a chrome-plated alligator clip?
Yes.
Okay, because the chromium will definitely give a yellowish stuff that people have tried before, and they said they got gold GaNs because it was yellowish, but it's actually chromium turns out to have a yellow precipitate to it. So I'm wondering about that.
This is my chromium.
Chromium, yeah.
Yeah. Made just the way I described it a moment ago, using the same voltage and so on and so forth, and it with the copper rod, or not the copper rod, but the carbon rods, and I don't know if you can see it, but there's kind of dark particles mixed in there, which I am assuming is part of the copper rod. I'm guessing at this point. So,
and what do you use for the chromium electrode? I'm wondering.
This a chromium rod.
A chromium rod? An actual solid chromium rod? Is that what it is?
That's what it is. I ordered it on the internet.
Wow. Cool.
So, all right. Denny, you wanted to know what kind of experiments I'm doing at the moment. Lately, I just saw on the internet that they published kind of the configuration for the eye treatment that Mr. Keshe is currently conducting. So I took that formula and I'm working on that with my eyes. I've got some calcium GaNs going here. I just, took some eggs, and many people on the internet say, oh, you got to crush them up and grind them up and chew them up and whatever. I said, well, I don't have any kind of grinding device here. So I said, hell with it. I'll just break them up as small as I can with my fingers and put it in the caustic and turn it loose. And that's after about 1 week. You can see the GaNs developing there.
Do you think you could use that eggshell and a carbon rod and see what would happen?
Yeah, sure. I just cook up some more.
And I don't want to run Mark off, because there's a lot of questions yet that I want to ask Mark too. So, but I'm not in charge here. You go ahead. No, you go ahead.
I only have one more thing. Rick had mentioned that vinegar will dissolve copper. Well, I'm going to put that to the test as we speak. And I figure if
And
Rick is correct,
now,
then I should end up with a copper GaNs.
okay,
Wouldn't I?
well, here's the way that the way it worked for me is I used vinegar plus salt, and as it turns out, if you combine salt with vinegar, like vinegar is what is the formula for vinegar? It's acetic acid, which is H3NO3 or something. No, it's something
It would act. It would act like an
HOOH.
electrolyte.
What happens is when you put the salt in, it accelerates the acetic acid, which is one level of acid, and bumps it up to HCl, because the chlorine from the salt combines with the hydrogen to form HCl. So the HCl has more strength than the acetic acid, even though it's
What kind of salt?
diluted.
What kind of salt?
I just used sea salt, but you could use regular NaCl. Would probably, just the iodized salt would probably work quite well as well. And this is a standard solution for cleaning copper. You use this, vinegar and salt basically on the brush, and it cleans up very quickly actually. But if you soak it, I soaked mine actually over the whole winter, left it out in the sun on the deck in a container, and it dissolved the wire, the copper wire, down to about a third of the size that it was normally. And the solution turns a really beautiful, beautiful color of blue, bright sort of blue, or deep, deep but bright sort of blue. And then you've got a vinegar solution with the blue copper dissolved in it, essentially, as ions. They're not as particles in there, they're ions in there. And then I decided, well, what am I going to do with this? And then I took the caustic and made some up into a strong, concentration, and poured that into the vinegar, thinking it might explode or whatever, but it didn't. It turned black immediately inside, and the particles filtered down to the bottom. And then I filtered them out and, took them off, and it's not a GaNs, that's the nano. It's actual copper oxide nanoparticles. Okay, black copper oxide nanoparticles. I'm not sure what shape or size they are, but I'm convinced they would be, well, it has to be. Because what happens is if you pour enough caustic in, the solution turns clear again. The blue goes away totally, and you can't get any more black particles out of it, because all the copper's gone out of the solution back into the copper, the element, or copper oxide, rather than the ion or some other form of it. So then you got these beautiful little copper oxide particles, and when you dry them out, it's a fine powder. It doesn't stick together and so on. It's just I'm going to actually use it to create a paint product. I want to paint with this black copper oxide, use that as a decontamination surface, essentially, because black copper oxide is known to decontaminate any heavy metal and virtually all forms of viruses and bacteria within approximately in less than an hour. 99.9% are gone in a black copper oxide solution. So it's an excellent purifying substance. So I'm thinking, if you painted a vehicle in copper oxide, for example, the black copper oxide made from that process, it should be able to actually purify the air as you drive through the air. As the air causes friction against the surface, the pollution particles get broken down by the copper oxide, and essentially it becomes an air cleaner rather than an air polluter. If you were to have such vehicles, or you could have fans that were coated in that material, and so on and so forth, different applications.
Well, in your opinion, Rick, what would I have in the bottom of this jar, 6 months from now? Would be some kind of nano coating, or is it
Well,
actually
what do you have in there? Say what you have in there again. You have vinegar.
just vinegar, and now I just put the salt in, like you said,
Yeah,
and copper wire.
copper wire, like 14 gauge wire or whatever pieces. Mm-hmm. Okay.
Correct,
Yep.
correct.
You've used apple cider vinegar. Is that right?
Yes.
Right. Well, normally it would be better, I think.
Exhibit A.
Right. That's empty though, right? So normally
Yes. Yeah.
that's the pickling vinegar. Is that what? Sorry, is that the pickling vinegar or
It
apple?
just says apple cider
Okay.
vinegar, all natural
Okay.
food choice.
Yeah, right. But that's the colored. It's colored because it's apple cider vinegar. The best stuff I think to get is the more potent pickling vinegar. It's called. It's
Right.
clear. It's clear, and then you can see the transformation in the copper as it makes the solution blue. You're going to get a combination of blue and brown there. It'll be kind of a muddy color instead of that brilliant blue that comes from the clear solution. So there's two kinds of vinegar. There's the normal vinegar you get at the supermarket, and then there's this pickling vinegar. And the normal stuff is 5%, and the pickling vinegar is 7%. So that's like 20% stronger acetic acid in the pickling vinegar. It's much preferred. Throw a little salt in, like a teaspoon or up to maybe a tablespoon per liter, something like that, a teaspoon per cup, or whatever. I'm not clear on the actual salt concentration, but probably somewhere around between 2 and 10% is probably about right. 20 to 100 grams per liter. And
Well, I'm one of those scientists that if a tablespoon is good, 2 tablespoons are better.
well, that's what they say about the chrome, right? If an inch of chrome is good, then a foot of chrome is better. That was the saying in the 1950s. But in
Yeah, precisely.
your case, you used a whole foot of chrome and went for it all the way. That was amazing, and it pitted it quite a bit, didn't it? It took big chunks out of that chrome rod.
Yeah, it turned it into a rust ball. That alligator clip is no longer functional. It dissolved the spring on the alligator clip as
Yes,
well
yeah,
as
I've had that happen before. Mm-hmm.
I'm sure everybody
Well,
else has
see,
had this
on the alligator clip, there's several different materials involved there actually, because you have steel, or some of them are copper, but it's usually a steel-based alligator clip. And then in order for them to chrome plate it, they have to first copper plate it, and then they nickel plate it, and then they chrome plate it. So you've got chrome, nickel, copper, and steel all mixed in together, and they dissolve quite well in that. They got galvanic responses going on, and acids and bases and everything else eating away. Then what do we have here?
This is nickel Gans.
Okay, yes. See, I think this is what some people get from their alligator clips when they're trying to get the gold GANs. It's a similar sort of greenish color, and which is sometimes associated with gold.
And this is nickel Gans with nano-coated copper, and it's kind of it looks black on the screen, but it's kind of a very, very dark brown.
Oh yeah.
And it does have a chunk factor involved in it.
And would that be also under power? All of these under power with a couple of volts, 1.5 volts or something? I think you said, and 0.05 amps. Was that it?
Yeah,
That's
it's all under power.
50 milliamps basically.
Yeah, I don't have the patience to just hook that up with a what's that thing? Capacitor between them or whatever.
An LED.
I don't have.
Yeah. People using LED.
I don't have any LED. Yeah, I don't have any LEDs on hand, and in Thailand, you just can't just run down to the electronics store and buy some of this stuff. So.
Oh no. So, I thought that you'd have one in every corner there.
No radio. There are no Radio Shacks, you know.
You can't get stuff like that in Radio Shacks anymore. You can barely buy a diode. You can barely buy an LED. You can't get the diodes. You can't get the resistors and transistors and so on that you used to be able to. They've gotten rid of all that stuff and just put in, junky stuff that's already pre-built and so on.
Okay, well, that's all I have for today.
Well, thank you very much. That was great.
Well, I could add just a little bit for you, Don. When you're taking that vinegar and salt and you turn it into hydrochloric acid, you're now creating an electrolyte, which is stronger than your sodium chloride. In other means it's not, I'll not say stronger.
Well, stronger is a good word. It says stronger field strength, and it starts ripping and tearing at, for example, the copper, or it would even have a go at gold. Gold, normally it takes really strong combination of hydrochloric and sulfuric acid, I believe, to dissolve gold. But
so it would be interesting to see how you might use the carbon rod in that kind of a solution, and a nano-coated copper to see if you would keep a nano-coated tube. If you nano-coated a piece of wire, it would be interesting to see if you would keep the nano-coated wire in a tube shape, the wire shape, without the copper in it. And
So you're basically dissolving the copper. Is that what you're after?
yes, and keeping the nano-coated tube.
right.
Well, the
tricky.
problem is that we're using the copper currently as a support system. We have not been taught yet how to make that nano coating stand on its own.
Yeah, we're trying to figure it out. We're trying to beat the teachers of ourselves, and so you would want to give it.
No jumping ahead.
Okay, well, I don't have anything more to add.
All right. Okay, well, thank you, Don. All right, does anybody have something else to add?
Well, I had interrupted Mark, and so I guess it would be I'm obligated to ask Mark, what more did you have that you wanted to share there?
And Menachem might have a question. He's got quite a few comments here. I haven't been paying attention to them all. So
I haven't either. I'm bad. Mark, are you still awake?
Yep, I'm here, Denny.
Okay, well, I guess we're going to Menachem first, aren't we? But you got some more stuff to show us, don't you, Mark?
Yeah, you know me, Denny.
Okay, I'm out of here. You guys go ahead. Sorry, Rick.
I'm just trying to read Menachem. He's saying, why not all share like a real class and know who we unite with? Sometimes when I'm muted or closed off cam, I am treated like a fly or some pest. Menachem, I don't think so. We're just focusing on one thing at a time here, one person at a time, trying to interact with them, and you're welcome to interact as well. It's just trying to keep on track with one thing at a time, basically. Anyway.
Yeah, Menachem, I'm a little more rude. I'll just jump in. So if you want to be rude like me, you go ahead and jump in.
Yeah, we all get a little bit rude in our old age, especially here in a way. I'm known for that myself, so excuse me if you feel insulted or otherwise abrased by me, but tough luck. That's the way it works.
That's the way it has to work. We have to have a host and we have to have a question. We only have so much time.
Yeah, that's right.
Besides, we all know you're a teddy bear anyway, Rick.
Hey, Rick, maybe we ought to go ahead and use the ham operator signal when we're done talking, say over. Maybe we can cut down on some of this stepping on each other.
Well, if you say over, there's still four others that are ready to jump in is the problem.
Breaker.
Yeah, we have to say breaker and over in order to communicate.
Breaker.
So, Menachem, you got that? You just have to go breaker, breaker, and we'll hand it over. Something like that. Well, we just do the best we can and try to get information out in the fastest and best way we can and have a good time with it all at the same time. And you'll just have to learn to go with the flow. Sometimes we don't go slow enough for some people to be able to get the full picture because we skip over certain things that we already know. For example, we just sort of barge ahead and assume everybody knows what GANs is and all these terms that we speak of. But at the same time, we have to backtrack sometimes in order to let people catch up and for us to jump ahead with a new idea that might be brought in by someone just out of the blue at the same time. So it's a tricky dance. We do the best we can. Speaking of dancing,
Yeah.
anybody else have...
Just to answer his question that he just came up in here, it says, so wireless system can illuminate an LED. Maybe we should accomplish this today. The wireless system is not an electrical generator, Manicam. It's a plasma system. You would need a receiver that's going to convert the plasma to electricity in order to get electricity out of it. This is basically what the MagGrav does, and this is one experiment I'm going to be doing when I get the wireless system done, is interfacing that into my MagGrav to see if I can get a more powerful MagGrav. But you need that conversion because plasma isn't electricity. Okay, I'm done.
Good. I'm wondering, of course, how you might accomplish that conversion. Would that be a coil system, do you think, with some kind of curly little antenna or something? Or do you have any vision on that, John?
Not really. The little bit of information that I have is the interface between the nano state and the matter state. That's where that magic happens, and I haven't quite got it all sussed out. It may be like a plate capacitor. One is nano coated and one is not. I don't know yet. I'm still trying to thinking it through.
Mm-hmm. One thing that came to mind to me today earlier was something that we've kind of glossed over and forgotten about on the nano coating and nanowire scenario. Something that Mr. Keshe said quite a long time ago. I'm just going to mute a couple of people here. I think Mark, maybe your line was open. That he originally had this energy device that was simply a coil of wire, and I think it was part of the Coca-Cola bottle deal or something, but it supposedly it was part of the flashlight, the everlasting flashlight that could light up the flashlight whenever you wanted without having to charge it, supposedly. So the whole idea with that self-charging wire, there was a part of that we've missed, basically, that we aren't incorporating at this point, which I just remembered. Once again, I've remembered it several times. And can anybody remember it? It brought up especially in, I think it was Eindhoven talk that Mr. Keshe gave several years ago.
The only thing that comes to my mind was his when he was talking about having the layers where you'd have AC on one layer, DC on another layer. I'd have to go that's way back. That's like a year and a half ago.
Well, that's close, but there is something specific you do with the wire that changes everything.
I don't recall. I'm gonna have to go back and start from the beginning and go through the.
No, I'll tell you in one sentence. Basically, you scratch the wire. You scratch it lengthwise, and that puts
Which again reinforces the
bare spot.
nano-material to matter state interface.
I think to me what it does is let me just do a screen share with the whiteboard just briefly. It's an interesting concept that will might run into, and I think maybe it's important, so let me just do it here quickly. I have to go to that.
While you're after that, Rick, I'm gonna just jump in here with the new capacitor idea, and then I'm gonna say over.
Okay, thank you. I'm trying to find the. Oh, I guess this will have to do. I can't find my annotation actual part here. Let me see if that can be. I think I have to go full tilt here on this. Well, I'll just see if I can just do it on the way I do it here. Basically, if you think of a wire. Oh, did you want to go ahead there, Denny, or?
No, I just wanted to put that thought out there so you would have it that you may want to go to at a certain point.
Okay. Okay, so say we have a nano-coated copper wire here. And then if you were to, like normally the nano coating would be all around the, all around the circumference of the wire and, all along the length. So it's one unit. Even the ends would be nano coated. So if we were to actually cut it along its length, to basically take a little chunk of the nano coating out. Oh, it's hard to do with a mouse, and that leaves a spot, and that's bare in the middle here. Let's say, so it's bare copper, and that means that the plasma is going to be affected by that bare spot. So if you look at this cross section, instead of an O, which we know what the fields are like in a complete O-shaped field. If we look at it as being an actual, more like a C, so the qualities of an O are different than the qualities of a C, especially in regards to the resonance. With an O, you can't have a resonance so much around the circumference. The fields will cancel out. So you won't have any back and forth resonance. The resonance would have to be probably lengthwise along this, or maybe just some other thing happening. But once you have a C, then all of a sudden you have these two endpoints. So they end up having a gradient, because one is always going to be going positive and one is going to be going negative. But as soon as that happens, then it causes the fields to move in this sort of fashion. But then once they move over, at least you think of it in terms of if there was electron flow. The electrons would flow to one side and cause it to be negative, and then when that happens, there's too much to one side, so it starts to flow back the other way, and then that becomes negative, this becomes positive, and so on. You'll have it starts a flow action happening. And that can be evidenced by, there was a contraption that someone put together that looked like this, and basically this a tube with two little balls at the end. They're brass balls, I think, and copper tube or something like that, and these would create a potential and an actual resonance depending on the size of the size of this. So they went and made another one around it this way, the ball here, the ball there, another one around this way with the ball here and the ball there, and so on, and made a bigger and bigger structure until it's about 6 feet across. And it turns out the little one that's in the middle, because it goes down to a tiny one in the middle here, and all of these resonate at different frequencies, but when the if one picks it up, like the big one picks it up, amplifies it into the next one down, which amplifies it into the next one, because they're all at they're all built according to, I think, the phi frequencies, or some relationship between each other to resonate and so on. Time it gets down into the middle, it's got a very powerful potential, and then it resonates back out the other way, and so it goes back and forth inside the structure. So now they've created on a nano level the same structure, and they've created in copper, and they create little things that look like this, and then the copper is inside this way, and inside this way, and inside this way, and they hook this up to a wire, and they have a grid series of these over and over and over, hundreds or thousands of them on a small piece about this big, and it acts as an antenna, because this is it turns out this is an ideal antenna. It picks up a wide range of, well, within a narrow range, but still a broad part of that range.
Breaker.
Hello.
Thinking about this antenna now, John was thinking about how to pick up the frequency off of the plasma generator. He could use something similar to this, right, John?
Yes, that was the point, actually. Thank you, Denny, for bringing it back to that point. Since this acts as an antenna, why wouldn't this wire with a slice in it act as an antenna? This is the core of what Mr. Keshe was talking about for the self-powered flashlight that gives off light whenever you want, because it's powering itself at night with this special wire that's able to pick up the ambient energies, because it's got a gradient. It's in motion. It's already in motion just because of its shape. That's what I believe, anyway. I'll swear by it. Okay, over.
Yeah, we could carry this on a little bit if somebody else wanted to too.
Yeah, I had a thought about this. What if instead of having that groove lengthwise, you put series of those C's horizontally that way, going around like that? You might be able to fix a frequency of those.
That's a great idea. That's exactly what Keshe was talking about, Sept. He was talking about it as loops, copper loops that go around the wire. But
Right,
no,
the
why not
latest,
just make the scratches? I think that's brilliant. And you could make them, furthermore, why not make them, if this was the wire, for example, and you put a scratch here, you don't have to make them all even spacing. You can make them even and then wider, and then really narrowed down, and then wider again in a certain beat, you might say. Maybe even according to musical notes, the distance between notes.
Yeah. Or maybe get 50 hertz by making, adjusting that, finding you might be able to get a certain steady pulse, or you can create a composite pulse, or who knows? I mean, I don't know.
There's a recent physics paper that came out, I think, last week, and they talk about wire and the traveling of high voltage, high frequency, like in, high voltage wires and so on to carry current, that they have these toroids that build, at least little donuts, that naturally tend to build on the wire. And actually, I know what it was. I'm sorry. There's two different things here, two different ideas. The thing they were talking about was in light. That light has these light toroids that form, essentially little magnetic fields that form around the light, such that it keeps it, just they naturally form, it keeps refocusing the light, keeping it into a really tight, narrow tube. Whereas normally it would tend to like dissipate, deflect out, they were saying. But these little donuts keep it all together. And yeah, I like this idea of scratching the wire. I think it's like putting little
Yes, and
donuts
Rick,
in there,
you don't have to
accelerators.
just rely on a scratch. You can put another ring around it too. To give you a different depth. So let's say Mr. Keshe was talking about putting a copper wire around it. You can combine the wire and the scratches.
And would you nano coat that wire, or would it be better off not nano coated? I wonder. Is it
Well,
supposed to block the plasma in a way, or how does that work?
we're using it for we're using it to store and release energy. We're using that capacitor battery is what we're after. And when you're saying that this acted like a source of energy for the flashlight, then it was acting as a battery.
Yes, it's essentially the way I look at it. It's both it's similar to this structure. It's not quite a battery, yet you can get power out of it. The same as this antenna structure here, you can get power out of it too. This is one of the ways they get power out of just close by, sticking something close by and having it pick up the magnetic power and turn it into power. And so this acts, I think, both as a capacitor and as a battery at the same time. It's like if you were to, for example, instead of having this short length of wire, if you were to have this in a coil and had it scratched at the same time in the coil format, then you would have both a coil and a capacitor and a battery built into one. So essentially you got all the parts other than the diode, which actually the nano coating works as a diode as well. You've got all the parts of a crystal radio, and all you have to do is hook in some way of listening to it to get the sound out, and you should be able to use it for communications, detecting, and you name it, because all the components are built into this one piece of wire. All it has to do is resonate. It has to be the right length and the right diameter. Like this diameter is critical, the diameter of the wire, because it is the distance around here that is your resonating distance. So if it was a bigger wire, then it'll resonate at a different lower frequency. The smaller the wire, the higher the frequency it would tend to resonate it with. So it would make sense, perhaps maybe it would require for a 60 cycle wire, maybe it needs to be, I don't know, an inch thick or something, like literally this thick.
I'm going to throw in another idea here for you too. You being a mechanic, when you put a plug in the bottom of the oil pan, there's a washer there that you'll put in there sometimes, and it's a crush washer.
Yeah.
And in other words, it's like a washer that's folded over on itself, and it's like it has a opening in it in a way, besides the center of it, but the wire itself is folded over on it. That's why it can crush.
Yes, okay, I see what you're getting to. But in that case, it's a full circle like this. But if you look at it sideways, you're saying there's two types of washer. You're saying the one that's kind of like folded over like that, basically, sideways, right? And it's got the two parts. Like it would the shape would be more or less like this crosswise, like that, and like this.
Yeah, and a lot of them are copper. They look just like a normal washer, but they
Yeah.
crush.
Yeah, it would have this C shape to it, in a way, but then it still has the circle though, which gets back to the difference between the circle and the C. So it would resonate this way, but not necessarily around that way, unless you maybe took a little cut out of the washer, and then you'd have the C shape resonating back and forth here, as well as the whole thing would resonate through the back and forth between there. Maybe just cutting one of those washers and nano coating it would make it into a plasmatic generator. In fact, maybe that's all you need to do to turn your car into a plasmatic generator, is to cut that slot and put it all back together. And of course the oil would bleed out of the engine, but hopefully the engine would be working on a different level by then. It wouldn't need the physicality oil for its continuation. Interesting idea. Literally could be true that that small of a device that was operating on a higher level with resonating at just the right frequency with its C shape, C-section, C shape, and plasma in the middle of it, all bouncing back and forth, could be very, very interesting. Yes, indeed. Okay, so I just wanted to throw that in there, that idea of this slot that Mr. Keshe seemed to, it was a big secret at the time, but he revealed it in a couple of workshops and a couple of times as come up.
I think we've talked about this before on your
we did.
class.
I think it's good to reinforce every once in a while. So
sure, I mean
and I like the idea, like just from discussing this, the idea came up of why not making the scratches or cuts, along the length of the wire, which is exactly what Mr. Keshe was talking about, in a way of creating these rings. They're creating rings one way or another.
See, in a way, you're creating some kind of eddy current.
Yes, that's right. And what happens in these ring configurations is one ring communicates, like if you were to have a plus and minus to the end of, like say it was high voltage going through this system, and it was a perfect insulator and then a perfect conductor, sort of layers of conductor, insulator. The first ring conducts to the second ring, there's an inductive thing that happens with rings, and it can actually increase the voltage. And then the next step can increase, the next step can increase. You can have a voltage multiplier system built into the wire, so that what comes out has a higher voltage than what goes in. So I think that's a fascinating concept, actually.
I'm wondering if when you make the scratches, what if you made the scratches not as donuts but C's, and you have one C facing one direction, the other C facing the other direction, sort of like something along those lines? Are those the reactors Renan those showed like the rings around them? I was wondering, are those connected are they donuts or are they C's? You know what I mean?
Right. I don't know how you get a copper ring. How do you make a copper ring to start with, and how do you get it around a coil or a wire without it being a C or having that opening there? Basically, you have to either
if you touch them.
You can crimp it, but if you crimp it, it's no longer such a perfect geometry and so on. And if
you're getting that C thing that you drew on the right, if you reverse them, do it like that. I mean, I guess it's easy enough to do. isn't it?
Yeah, it's almost like jewelry work with, you could use a magnifier and, you could see. I would start with at least a 10 gauge wire, I think, because if you start out trying to make tiny little C scratches on 22 gauge, you're going to run into some difficulties. But I mean, it's all completely doable on the nano level as far as that's standard procedure and any kind of laboratory that's working on the nano level. But for us, we should be able to scratch, I think, down to 16 gauge or something pretty easily and come up with some sort of reasonable nano coated wire with scratches in it. That scratching is not quite the right word. You have to, it's more like machining little slots in the
And I,
wire.
Oh, you could probably do that with a piece of copper pipe. It would be so much easier to work with.
That's
yeah,
true. That's true. Copper pipe would be better.
yeah.
Probably. I think that's right. That absolutely makes sense. I mean, maybe
Yeah,
we
just
can work down
make
to the
sure.
wire level, but copper
Big
pipe
enough.
seems like
Big
it'd
enough
be
you don't need
better.
a magnifying glass to use or whatever. Yeah.
Mm-hmm.
Yeah, when
And
you go get your copper pipe, just make sure it's soft copper. The hard, rigid pipe is it. I've tried nano coating and making gowns with it, and it doesn't work very well at all.
Uh,
good point. Mm-hmm.
It, it, it you can do it, but you got to be really talented, John.
Well, I think it's because the rigid copper has a component of either tin
Yeah,
or some
yeah.
other thing in it.
You have to anneal it a little bit with the
Yeah, I was
torch.
going to say, even if it's work hardened, it'll make it harder to nano coat because it's just naturally harder for the
I
oxidation
have one
process
of
to
those
occur.
washers in my hand. If you want to, one of the things I can do is I can draw it here on the board, but I have
Whoops.
to.
I thought you were going to show something there, Danny.
Okay, well,
Oh,
you'd have to do
there
it.
we
You
go.
can't see it; it's so small. It's easier to draw it on the board, and the seam of this crushed washer. Yeah, I forget what they're called, but they flatten,
Yeah.
so they form a seal better, and so it's round, and they're folded over, and the seam where it meets is on this surface right here.
Okay.
As I run my finger across it, I can feel the roughness of it. With a magnifying glass, I can see it, but I don't think we can pick it up. We might be able to on the.
Yeah, it seems
But
like it.
that's where the seam is. It's on this
Okay.
face here,
Yeah.
and that's why I brought up that idea, because I was to get smaller ones of these and put on that newfangled capacitor battery,
Oh, yeah, yeah.
and so and a
Yeah,
regular
interesting.
they have regular copper washers too.
I
I
think
have them.
that's a great idea. I mean, if you look at it, look at that example. That's a good example. It's a little different than the one I was thinking of, and like you say, it has its gap right on the top surface here. The other one I was thinking has it on the edge or the outer edge, you might say. So, but you can imagine that on a capacitor bank or even a large coil setup or some sort of imagine a large wire essentially of pipe or something, and have
Yeah,
that
I don't
around
need to
it.
have my video on anymore. Over.
Okay, that worked better than drawing a picture. Thank you, Danny. Um, but it just reminds me that coil could it definitely has special properties when you think of it as in a plasma concept. It's just looks like it's going to be an amplifier, essentially. It's a toroid amplifier. Okay. So getting on here. I'm getting a little. I'm starting to babble. I think I might have to shut down here soon. Any other comments or things that people want to share C. Ask. Alper says, too late for me. I have shared a video on my Facebook. Here's the link. I'd like to see what you think of it. I'll say thank you kindly. I'll leave it on. Menachem says, Breaker, does a freezer also contain a compressor or just a fridge? Nope, freezers have a compressor and fridges have a compressor. Very similar deals there. More in the flashlight that collects free energy. Yeah, that's on the Eindhoven, Eindhoven. I think it's spelled. If you look up Eindhoven and Keshe, you should be able to bring up that video, and he explains about the free energy flashlight there.
Yeah, they probably don't call it a flashlight. They probably call it a torch.
Yes, that's right, Denny. I think that's right. Okay, what else? Who else? Am I missing something? Pia, hi, how are you doing and how's your hand? Have you tried to help it with anything yet?
Did you call me?
I was wondering how your hand is.
My hand is a little better, but not yet good. But I had to go and start to find a serum to transform the gas water. You know, they don't, all the other people, they don't know what's going on. But I told you this morning that I had got a sting from a bee.
Mm-hmm.
Or whatever, and my hand was wounded. Yeah.
So have you tried, what are you doing with the GANS water again?
Yes, my plan is to go today to buy a serum because when I read the paper, they're stating it's best to transform the water through a serum to the paper.
So Pia, this is Denny, and
Hello,
and so it was a bee.
Yes,
it wasn't a wasp. It wasn't a hornet. It was a bee.
It could be a watch too. I couldn't see it.
Okay. Well, do you have onions?
Yes.
Well, just take you an onion and slice it and get a little bit juicy and put it on the sting. That is one of the old ways that you get rid of the sting out of a bee sting, and even as nasty as a hornet sting. And there's another little plant that's called plantain, but you kind of have to know what it is. There's a couple kinds, and you can usually, when you get stung by a bee, you'll look around and you can see that plant, and you'll take a leaf off and crush it up and put it on the bee sting. But if you're in the garden and you got an onion right there, just you slice that onion open and squish it up a bit so it gets juicy. But you got one in your refrigerator probably, or in your kitchen. You slice it open and you'll be surprised. This happens even with people who don't have their bee sting serum because they're allergic to bee stings. They can quickly use onion and put on it. The bee sting goes right down, and the sting, the feeling of the sting, the pain of the sting goes away quickly.
Does it still work a day later, Denny? Is it still effective then? I think it's been about a day since she's been stung already, and she's
it does work, because and it's still it has the plasma field in the onion. You know, an onion is a series of leaves. You look at the onion bulb, is actually a series of leaves, and so when you cut it open, it's actually a bunch of leaves. And so the plasma of that onion evidently affects the plasma of the venom of the stinger, and probably equals that. So we're talking plasmatically here. We're not talking old wives' tales. We're in the plasma plasma group here. We're so that's when we're saying put onion on there. We're talking about the equalizing the plasma strength of the venom and the onion.
Yes, yes. I understand. That's cool. That's true. I
Are
have
you
heard about this onion. That's true. I didn't thought about it. I got in panic when I saw this, swarming up, and it was 2 days ago.
so do you have an onion right there right now?
Yes, I can do it right now. Of
Oh,
course.
yeah. Do that and see how quickly are you in pain now?
Not so much as yesterday, but still, it is.
So, but it still has it has raised a bump on your skin. Is it
Well,
red?
it was really severe the first day, is the way I understand it. She had to get an anti-allergy thing from the doctor and so on.
Okay. So
Because
it's
I think you were bit
already been
on the
taken care of.
wrist. You were bit on
But
the
it's a
sensitive
very
part of the wrist. Was
good
that
one.
true, Pia?
What did you say?
You were bit on the sensitive part of your wrist. Is that true?
Yes, and then the swarm went to the whole hand.
Okay. Yeah.
And so I would like also, because it's the first time I have to use my finished new ganses. So I would that's why I want to ask you if it was. Of course, it can be used for swarm things, but I've just never tried it, and just want to hear your opinion about that with the swarm things.
I would
Swarm
tend to use the CO2 GANs and zinc oxide GANs mixture.
Yeah, I would
Make
stick it right in the GANS water. If you had some GANS CO2 GANS water,
and maybe even I would even perhaps make a paste with some of the actual GANs right in it, and I would apply it to my skin. I wouldn't worry about it. Hey, that reminds me. We talk about zinc oxide and whether it's whether we should be touching it and so on. There was an ad a few days ago on the CBC News. This big ad comes on with this baby bottom, and the mother's taking care of the baby and so on, and they are the material used, this special ointment. They specifically said this is zinc oxide, and they were praising how it's zinc oxide and how pure it was and how good it was for the baby's skin. And I just went, I mean, and they specifically said zinc oxide, nano zinc oxide. This was not just zinc oxide, but nano zinc oxide, right in this national TV ad. And I thought, okay, this is quite interesting. Of course, this is part of a pushback because the Europeans were trying to regulate the nanomaterials, especially zinc oxide, which they are finding in the environment and so on, because it's used in so many cosmetics and other types of applications for skin creams and that kind of thing. And it's because it works. It's known to work for a long, long time. Anyways.
Okay, but now you're talking about this to put, for example, the hand right in the CO2 border.
For example, pardon me,
Yeah, and I just want to ask, so since you moved from not touching the water, and today now we have got so far in the research that we can actually touch the water and spray it directly on the hand, or
yeah, well, see, a lot of the the initial stuff that came out, like with Mr. Keshe and so on, he was always pretty much okay with certain kinds of GANs, with touching it and so on, but he didn't want to tell everybody to just go ahead and touch it and use it and so on, because number one, the tests weren't done on it anywhere near to where they have been at this point in time, And the main thing is that people aren't able to make the pure GANs. They think they've got, for example, when Keshe makes CO2 GANs, he makes CO2 GANs. He doesn't use the sea salt technique of putting the sodium hydroxide or caustic into the sea salt water, and you get this same white fluffy substance. And everybody thinks, oh, that's CO2 GAN, so we can use it just the same way as the CO2 GANs. But no, we've created CO2 GANs with every other element in the universe already put into it. So yes, the CO2 GANs is a certain percentage, but it's also got all this other stuff that you wouldn't necessarily want to be ingesting, putting on your skin, and otherwise using when it's multiplied by thousands of times in a GANs condition. So the same viruses and bacterias and everything else are being multiplied by thousands of times. You want to put that all in your skin at the same time? Maybe not. So the purity makes a huge difference, and if you tell people, yes, spray it, yes, use it, yes, eat it, or whatever, of course they will, and some did, and some didn't have the greatest experiences because they may not have had the purest GANs, or they used the wrong kind of GANs, and so on and so forth. There has to be a whole educational process and knowledge that's involved with it to learn the proper applications and so on. That's why we come up with that, people have come up with that plasmatic first aid, which I'll just, maybe I'll show that here briefly before we go soon. The plasmatic first aid paper, which I mentioned to you, Pia, to maybe you could go off of that. It's something that
Really good one.
it is nice, and I think it'll be made even more simplified and better as it goes along. It's gives the uses of GANs and how to make the GANs water, and different systems, the ways to use it, not just the uses, but the ways to use it. Like as a spray, number one. Number two is a compress. Number three is a drink. Number four is inhale. 5 is bath. 6 is stand or lay between. And 7 is the rotating reactor kind of protection thing.
Breaker.
Hello, Denny.
It's the bath.
Yes.
You got to be careful what kind of GANs you have in your bath, and even the GANs water, because if you put your head under the water, if you're heavy with the copper oxide in your water, you will come up with a headache, and you may even come up with being off balance.
Well, that's a good point. Yes. So, yeah, bath isn't mentioned too many times, and mostly the radioactive contamination. I see most of these systems seem to skip over bath. Although it's an internal injuries, you can see it there.
I have this little swimming pool,
Mm-hmm.
and I had it specifically for putting liquid plasma in it.
Mm-hmm.
The swimming pool was on the outside was 6 feet wide and 10 feet long. So what is that? 6 feet? It's 2 meters wide and a little over 3 meters long.
Mm-hmm.
And it was air filled. So the inside, so I probably had about 150 to 200 gallons of liquid plasma in there.
Yeah.
And I used the zinc and the CO2 and the zinc combination. And then I got a little bold, and I used some copper. And I says, well, if I'm going to do copper, I might as well put some CH3 in there too. And so there I was. And then I said, well, I know I'm not supposed to put the actual GANs in there, but you know, it's so pretty and it's so white. It's so pretty and it's so green and oh yeah, and that. So I put quite a bit of the CO2 in there, but it was the copper I was concerned with. And so when I laid and I floated in that stuff, and I had my head back and I tried to get up, I was dizzy. And I said, now I know that this stuff can affect you. And so I got out of it and I said, well, I'll try that one more time. Maybe I was
Maybe
just
it's a fluke. Yeah.
Yeah.
Yeah, I always burn myself twice just to make sure it wasn't a fluke.
Yeah, I want to make certain that if I blistered once,
Ow! Oh,
I
jeez.
blistered again.
Ow! Yeah, I really did burn myself.
And so I did that. And so, and it was fun laying in there. Of course, I'm laying in cold water because
well, that could be enough to give you a headache
because this is
in
outside
itself.
and it's covered up in a little tent type thing, and so it was fun. And then when I started to get out, well, I listed to this direction and I listed to that direction, and I said, "Whoa, Nelly!" But I got out and I sat on my chair and I recuperated. So I then said, well, from now on, I probably should not put GANs itself in the water. I should just actually use the liquid plasma. And if I don't use the liquid plasma, don't ever put your head under the water for because I lay in there floating and having, a good relaxing time. And so I was there probably at least 5 minutes.
Yeah.
And
if we look at our chart here, our chartomatic, and we look at internal injuries, for example, where they recommend you take a bath and add the copper oxide GANs water to it, they recommend, you can see the CO2, zinc oxide, let me get my pointer here, copper oxide, CO2, zinc oxide, and amino. So it's actually quite a high percentage of the copper oxide to the others, but it's 5 drops to a liter basically. And you were talking about, say you had 100 gallons in your setup, is that what you mentioned, or how many gallons? Danny?
Yes, I was muted there for a minute. Yes, I figured there was at least 100 gallons to 150 gallons.
Let's say 100 just for a round number. And that was times 4, roughly 4, maybe 5 liters, depending on what your gallons are. Say 500 liters of fluid, the GANs plasma water that you're lying in. So 500 liters times 5 drops per liter would be 2,500 drops. And I'm not sure how much that would actually be, but you probably put in 10 to 100 to 1,000 times more. If you actually put the GANs in there, then it would be making all of the water in there into the GANs water essentially, instead of just the GANs water added to the normal water.
Oh, so you want to know how much actual GANs I put in?
Well, yeah, in terms
I'm going to flip on my video.
I'm trying to figure.
You see this jug here in my video?
Let me make this so that everybody can see. I have to stop my sharing in order to get the full appreciation of this. Okay, there we go.
You see this jug?
Yeah.
Well, I put about 2 of those jugs.
Oh my God. Really?
Of those jugs in the bottom of that.
Yeah.
And I made certain. See, this one right here is mostly zinc, because you can tell
Does it have any bluish or greenish tint to it? That one?
No, this is the color of mother's milk. I mean, it's white. It's
pure
white
as the driven snow. Yeah, thank you.
And so,
yeah.
Well, I've been. I drink the GANs water off of this stuff here in another situation.
Yeah.
But
so
I had some that was.
Still, that could be almost okay, I would think. But what about the more critical copper oxide? How much of that?
Oh, the copper oxide was mainly
the water.
salt solution with some GANs. I had a, let's say I had a, I'll do this. So
Was
that,
it quite
yes.
bluish, your solution that you put in, or?
See this jug here?
Uh-huh.
I'm trying to get it out here so that you can see the depth, the size of it.
Yeah. It's pretty big.
So I had about, it was full of the salt water, and I said, well, you know, salt water into this amount of water that's in this swimming pool would be negligible. So I'm not going to wash the salt out of it. I'll just pour the salt water GANs into it. So I poured about the half of this container, but of course this container is CH3, and I poured half of that container of the salt in there, and a little bit of course, the GANs material went in with it, and that's why I said, well, I know that Renan had used his salt, his plasma water. He would just take the salt, and he would take 10 milliliters of the salt water and a liter of distilled water, and that's what he would make his liquid plasma out of. I don't know if he's graduated from that or not, but that's what he used to do. And so I think I had a fairly strong mixture, even though I didn't know I did.
I think so, yeah.
And so, but the fun of it is, now I have to figure out what to do with all that water.
I was going to say, that's my next question. What are you going to do with all... I'm thinking, well, how's he going to pawn off all this water? He doesn't want to just dump it into the environment. On the other hand, you want to have some good use for it.
It's got a lot of CO2 in there.
You could you could have a heck of a combo reactor there.
And for personal amusement.
A rotating pool would be quite amusing.
And I did get that. I got myself a 12-foot round swimming pool to make that liquid plasma in, because if I can make this much liquid plasma in 40 gallons
then a foot of chrome is better. Yes.
In a day, then I don't know what's going to happen in the world.
This is a good idea, actually. Using a kiddie's pool to make massive amounts of the GANs material would be a great great video to do, actually, because in a survival situation, not everybody's going to be out making GANs, but some people are, and going to want to be needing to do it in a major kind of way. Because if one person has to supply, say, 10,000 people worth of GANs for their continuity for a few months, and that might include everything from decontamination, from radiation or some other biological thing where people have to take a couple or 3 baths a day and CO2 GANs water, and you have to create swimming pools full of it. Maybe that's the way people will do. It'll become known. Joe has a swimming pool full of CO2 GANs water. Just go over and dip your bucket in it and take what you need.
The difficulty is making certain that all the leaves and the trees don't fall down in it, and all the bugs that want to take a drink out of it don't live in it.
Well, there's your amino acids, and your this is where Mario comes in with the life and the iodine of a bug, for example, and and using the things in your natural environment. I don't know.
So so Don, just so you let you know what you started. Are you still there?
Oh yeah, I'm still here.
Well, so here's some of my carbon rods there. And, those are the gouging rods like you have. And I found out it makes no difference whether I take the copper off of it or and just use a carbon rod. In fact, I like to leave the copper on it. And so, but I found out that when I'm making the CO2 GANs, that primarily the CO2 GANs, that I really have to keep my amperage and my voltage fairly low. Voltage just naturally goes lower when you use a lower milliamp, and that way I get the fluffier GANs. But when I go even when I go up to like 150, my GANs becomes more zinc oriented.
More heavier and denser, like.
Yeah, like this. So because I'm using such a big, like I'm using 33-gallon barrels, and I'm using a big tub that's 40 gallons, and so when I go out there and I look at it and I see what kind of GANs I want, and if I want a mixture, then I'll change the
electrode
amperage. I'll change the amperage.
Yeah.
And I found out that I can use just I use well, here's one of these things, but it's not hooked up. It records the amps and the voltage, and I hook that into a one of these little things here, one of these little wall warts.
Yep.
So I have a bunch of those, and I haven't got my experiments going because I had to take time to build my building to do my experiments. And at the same time, my wife wanted a chicken house, and so consequently, that's more than the material. I wasn't advanced enough to make an oasis system for the chickens. But that's what I want to do. So anyhow, that's just for the fun of it. I thought I'd put some more amusement into this meeting, because
breaker.
Yes.
Danny, you've got the breaker down, but you forgot to put the over.
Oh yeah, I don't know how to do. I get so far along, I think over is under. Over.
Well,
no, that's a shotgun.
Over and under. I think we should go over and out here pretty soon. We've gone on for a very long time, 4 hours to be exact.
Yeah, but you guys, you're
having fun.
You're too
though.
tired right now. I'm just all wound up. I'm still wanting to see what Mark had to do.
Oh, Jesus.
You better say that. Hey, Mark, you got one more comment?
And also, we have Menichem's got a whole bunch of comments here that we should probably address. Like, for example, if you have a metal plate in your body, can you use a maggrav or a Q device? I think you can use a maggrav, but I don't know how it is for healing and so on. The jury's out on that. Mr. Keshe doesn't recommend that people use the plasmatic stuff around if you have a...
Rick, you got to take my picture off of the front here.
Okay. Let me spotlight my picture instead. I think Mr. Keshe has said that it's a problem, basically, if you have a metal implant, as far as using some of the plasmatic devices. But on the other hand, Douglas has had some pretty good luck with the things that he's done. He's had near miraculous response on his back since he's encountered the Keshe technology. So I think it's a lot dependent on exactly what you're doing. If you're just putting a maggrav device in your home, I don't think you have to worry about metal in your body so much. But metal in the body just naturally attracts, as metal does, and bodies do, different kinds of fields and waves and such forth. So it's probably not good to microwave yourself if you have metal in your body, for example. So don't microwave yourself anyways. It's not a good idea. What else here? Tests with aquaponics and fish to see how it works with safety for humans. Yep, the copper tends to kill fish, so we just keep away from the high levels of copper. If I had the chance to talk about the wireless system, I would compare pictures on wiring and how all the designs of builds so far are all different. As Mr. Keshe said, most built it incorrectly. Okay, let's see your system and compare the pictures. Gordon says, would you share more of the details of making CO2 GANs with rods? With rods. I think he means the
Carbon rod.
Carbon rods, yes. First we get the lightning, then we get the thunder, over and under. Okay. He said, no, don't use it, but why? It's got to do with the possibility of the body rejecting the metal, is the way I understand it, because the body will start rejecting everything that doesn't belong in the body. So everything gets sloughed off. So that might be a problem as far as things like that that are in the body. Okay, copper and carbon rod. Copper must have an outcome, yes. Okay, Menachem says, at first my dad became agitated and I was worried. Then I asked him if he would prefer I unplug. He said, leave it then. Then he felt better, thank God. It's now in for 2 months, nearly. Yeah, I think that, generally speaking, that's probably a good thing. I don't think there'll be any harm in having a MagRav unit to make things a little happier in people's lives, take away some of the stress and pain. Chinese call it the happy box, so it's got to be something good there, and I don't think it will cause a problem. I'm talking about some of the more intense treatments, more or less. Mr. Keshe advises on how to set up the coils directly on your, next to the body, and more powerful units, more powerful fields, and so on. Okay. Anything else? Any other comments from anyone there?
Over.
Over, yes, sorry. Guy, you've been very quiet. Anything you want to say or bring up before any reports on your work that you're doing there? Or have you gone to sleep? I'll let you unmute if you see fit.
Did you want to have somebody talk about making the CO2 GANs with the carbon rod? Because Don is here. He's done it quite a bit. I'm here. I've done it quite a bit.
Okay, well, if either one of you or both of you can explain.
Breaker.
Okay, go ahead, Don. Over.
Denny, you are the master. I mean, you've made more GANs than probably half the Keshe population. So I think you should go forward.
So Don, I watched
Over.
one. Yeah, Breaker. This is Denny. So Don, I watched one of your YouTubes, and so you explained there was a carbon, the gouging rod. So I bought gouging rod because they were very cheap comparative to ordering up a high grade carbon rod. And of course,
Breaker.
yes.
Denny, I think you have me confused with another Don. One, I've never made any YouTubes other than what we're doing right now on this plasma program. But the rods that I use were just solid copper or carbon, rather solid carbon. No copper coating.
I have often been confused. So, and in this case, Don, I am definitely I definitely mistook you for the other Don that was on the video, and he was using gouging rods. So go ahead and explain because I use the gouging rods and I find that they work quite efficiently. I find that also that I don't need as much salt in my solution, because I look at the sodium chloride also as an electrolyte in a way. And so I don't need as much salt when I'm using the carbon rod, and that means I don't have to wash as much salt out. And when I'm wanting more CO2, I definitely keep my millivolts. I never go higher than a volt. I use a power supply on so that I can know my amperage and my voltage. If the person who wants to know about the carbon rods, they'd have to know what a power supply is. And some of those you can get them for around $78, and usually you have to buy them online. And those that are about $78, they take a while to get to you. Depends on where your location is. Where I live in the United States, and so but I found that I don't need $78. I said, okay, if I'm going to be making a lot of this, I said I would let me find a way that I can get a power supply for under $200. I mean, under $20. And I've got the power supply system down to $15. I had one that I got for $10 because I had these little they called wall warts, the old 12-volt power supply that hook into the wall and hook into your phone, or hooked into a little other kind of a DC operated system. And I know I'm going on for a long time. So the most important part of it is to pay attention to your amperage. Keep it down below 100 amps if you're trying to work with making CO2 cans. You're going to use
100 milliamps, not 100 amps, right?
Yeah, 100 milliamps. You got to keep it down in the milliamps, and I keep it under 100 milliamps, and I keep the voltage down less than a volt. Especially if you're dealing with 100 milliamps, it's easy to go less than a volt because you don't need that. Your voltage isn't the important thing. Your amperage is. The other thing is what was it? Oh, what was I thinking? Your zinc, the distance from the zinc and the copper rod. I've made it in smaller containers, but I went to the larger container because I just do that kind of stuff. And so I used a 40-gallon tub. And so I found the distance between the zinc plate and the carbon rod did some importance in not eating up the zinc plate as fast. And so you're trying not to eat up that zinc plate. And so that's one of the reasons why you go a smaller amperage. You can get down there. What is it? So it's you get down. I know I went down to 20 milliamps and still had production. And I moved my plate farther away, and the reason I know I'm not making a straight CO2 in that container with this rod is I wouldn't be eating up that zinc plate as much. I've got to be making zinc oxide when I'm eating up that plate. And so there's a couple other ways to go to make the actual CO2, and that is to use one carbon rod as the electrode and the another carbon rod as a diode. But you've got to be very, very careful to keep that amperage down really low, and you want to keep an eye on it, because otherwise you'll turn out eating up that the anode. The anode would be the one that's got the positive charge, that's a positive clip to, and you want the negative clip. See, that's what I didn't tell you about it. You want the negative clip, or the black clip, on the electrode, the carbon electrode. You want the red clip on the if you're doing the CO2 or zinc, you want the red clip on the zinc. So I forgot to say that. And so if you're using a carbon rod and another carbon rod to make your CO2, you try to use as little as amperage as you possibly can. Otherwise, you will eat up the anode rod that's on the positive clip, and it'll just turn your water black, and the stuff that you have at the bottom, you don't know what you have.
Yeah.
You don't know if you got a carbon. You don't know whether you have a carbon GaNs, and you don't know whether you have a matter
copper
carbon
oxide or something. Yeah. Yeah.
And so you have to be very careful in that particular experiment to keep an eye on it. And because what happens with these carbon rods, you don't keep an eye on them, because everything is, oh, that's just going great guns. You walk away, and a night or two you come back and you got a gallon of that stuff. And you clap your hands and say, well, I'm going to wait. I'm going to do this for another week. And then and before too long, you got enough to fill a swimming pool.
And you're looking for another swimming pool.
So that's it. If anybody had any questions, I hope they don't, because we're running out of time. Rick is Rick wants to kick me now. So good night and over.
We're now 4 hours and 15 minutes into the show. No, it's all good stuff. Great information. I thank you very much, Denny. It's really it's good to it's the whole show's been great. There's been lots of information. It's steady flow. Darby, this will be the last question, I think. Any confirmation last week's suggestion of connecting 2 magravs back to back and saving 75%? Anybody have any replications they've done of that? Or I've heard of, I think, 1 or 2 other replications. I can't remember who it was from right now.
Lee was doing that, but he hadn't got it finished. He had that was the system he had in the bucket.
Right.
I don't know if Lee is still here.
And so I'm not sure. I know there's other groups around the world that are working on this and have had success, according to some reports. I just don't have any solid links or connections or pictures yet of those setups. So we'll hear more as things go on. Maybe we'll hear more in the Knowledge Seekers workshop tomorrow.
I can share my biasness. I'm still going for the total off grid, because if I'm out in my backyard and I have to run wires out there to to get 75% out there. 75% of nothing is still nothing. And so my bias is to get a complete off grid.
Yes, that's definitely the objective, I think. It's time to get wean ourselves off the grid and get off that milk run. Okay, gonna end things for now. Thank you, everybody. Great fun. Glad you could join us for the Keshe Plasma Reactor Group. It's Wednesday, September 14th. We managed to get through the 13th easily enough. No disasters. Not even a major argument tonight. We're doing good. Okay, thanks everybody. Let's end the live stream for now. And oops. Over?
No, that was over. But I just thought if you wanted an argument, I could probably give you one.
No, you won't get an argument from me. You'll get the delete button as we go off the air. No, go ahead. Is there something else you want to say there?
No, good night and thanks. And thanks to everyone.
Right on. And it's over and out now. So I think this is a good way I like this breaker thing. This is a good way so that if somebody has something they, just got to get out right now, it's like breaker, and that allows them to break into that conversation and so on. As long as the other person says over. Okay, on blah, 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 over. And that ends that, it makes distinct sort of encapsulated parts of the conversation. I think we can thank Menachem for that contribution that led to that. Helps us get more organized, perhaps. We'll see if it carries over till next week. Okay, really end the live stream this time. Okay, really end the live stream this time.